Why do people not know that vitamin D deficiency can increase dementia risk by 80%? Why do people not know that having a lack of this mineral is affecting their long-term risk of cancer? Why do people not know that having a low omega-3 index is as bad for you in terms of mortality as smoking? And as a scientist, I've seen firsthand that 70% of the way you're aging is actually due to your lifestyle. And all these things are so easy to do. So, for example, as we age, certain areas of the brain, which is involved in learning and memory, starts to shrink by about 1 to 2% per year. The good news is, studies show that people being part of an exercise protocol, not only did they not have their hippocampus shrink, it actually grew by 1 to 2%. And there's more. There are other things that don't even require as much effort as exercise, like supplements. And it's been shown study after study that if you take someone and you sleep deprive them for 21 hours and give them 25 to 30 grams of creatine, not only does it negate the cognitive deficits of sleep deprivation, it makes people function better than if they were well rested. And then there's magnesium. There have been studies showing that people with the highest magnesium levels have a 40% lower all-cause mortality, and over 300 different enzymes in your body need it to help with short-term survival. And yet 50% of the population in the United States does not have adequate levels of magnesium. And there's still more. There's saunas, red light therapy, ketogenic diets, blueberries, electrolytes, and we can talk about all of them.
Please.
Okay, so I've found when you go into the sauna, something happens that's incredible. So
just give me 30 seconds of your time. Two things I wanted to say. The first thing is a huge thank you for listening and tuning into the show week after week. It means the world to all of us, and this really is a dream that we absolutely never had and couldn't have imagined getting to this place. But secondly, it's a dream where we feel like we're only just getting started. And if you enjoy what we do here, please join the 24% of people that listen to this podcast regularly and follow us on this app. Here's a promise I'm going to make to you. I'm going to do everything in my power to make this show as good as I can now and into the future. We're going to deliver the guests that you want me to speak to, and we're going to continue to keep doing all of the things you love about this show. Thank you. Dr. Rhonda Patrick, you strike me as a fairly obsessed person. What is it you're obsessed about, and why are you obsessed about it? Because I can see from speaking to you previously how passionate you are about the subjects we're going to talk about today. And so I was wondering what it is about these subjects that is driving you and what you're trying to accomplish.
I've learned through my experience. So I have a PhD in biomedical science. I've done research on aging, on cancer, on metabolism, nutrition, neuroscience, a lot of different fields, very cross-disciplinary. And I've realized over, the decades of doing research that there are many different small changes that can be made that have a really big impact on our health, what's called our Healthspan. So this is essentially being disease-free throughout our life, being healthy, feeling good. And I'm sort of obsessed with trying to optimize that and find a protocol to optimize it and then share that information with the world. And it's funny because, we live in a time now where we've got access to so much information, overwhelming amount of information. But the reality is that simple, important tools that people can do in their life right now to drastically improve the way they age are still not known to the general population. And so my mission is to get that knowledge to people so that they can make these simple changes and live healthier and feel better.
And what will be the impact on their lives if they understand that information and start to implement that information on a real sort of specific practical sense?
Well, there are things that people are deficient in, for example, that they could simply take a supplement. Vitamin D is a good example that could affect their disease risk, their dementia risk. So you're talking about quality of life improvement right now and also later. So it affects mood, it affects depression, and it affects your neurodegenerative disease risk like dementia and Alzheimer's disease. So there are low-hanging fruits, things that are simple that you can just basically fill these gaps. There are things that are also a little more effortful. And this is where exercise comes in, where you put in this effort and if you could pill up what exercise does in a pill, it would be the biggest blockbuster miracle drug out there. It'd blow Ozempic out of the water. It'd be, just no comparison. So I think that, again, that it's these little things that you can do that is going to help with depression, help with mood right now, make you feel better right now, give you more energy, help you be more focused, help you be more motivated, but also affect your long-term disease risks so that, when you're older in life, you're not demented, and that affects you, it affects your family. So I think it's just it's so important because there are easy things that can be done that people just don't know about.
Is there a psychological element to this where we kind of see aging as an inevitability, so we don't fight it? Because we only seem to interfere with and fight and are motivated by things in life there where we feel like we've got an element of control. And we see everybody get old, and we see everybody start to, lean over a little bit and struggle to walk and get a little bit more frail. So I think because we've observed that so much over the last couple of decades, I'm just over 30 years old, I assume that will happen to me. So I've seen my dad, get older, get a little bit more large, lose his lean muscle. So I think, well, I'm like my dad. I've got some of the same genetics. That's inevitable for me.
So genetics does play a role in the way you age, but it's a small role. In fact, 70% or more of the way you're aging is actually due to your lifestyle. Let's just imagine two 70-ish-year-old men, okay, John and Rob. And John, he's razor sharp. He can carry groceries to his car. He doesn't get out of breath. He's feeling healthy. He can walk efficiently, right? And then there's Rob. And Rob is forgetting his words. He's not cognitively sharp. He's out of breath just from walking to his car. He has a really hard time carrying groceries. Genetics only plays a small role in those two different outcomes for those two men. The biggest, I would say, thing that's dictating the way these two men age is their lifestyle, with a huge part of that actually being exercise. Mm-hmm. And, I know we've all heard it from our mother or grandmother, great-grandmother, exercise is good for you. If you eat healthy and you exercise, you're gonna be healthier. And that's like a general statement. But the reality is, it is so true that exercise affects everything, down to the molecular level in terms of like the way you're aging. So, no, it's not just dictated by genetics, and it's not inevitable. And there are things that you can do to dramatically age better.
So let's play a little game here. So imagine that I listened to your advice and the things that you know about health, longevity, aging, and I followed all of them, which is very hard to do because, implementation is not the same thing as knowledge. So imagine that's person A, that's Steve A. And then there's Steve B. I do the exact opposite. Based on what you know about the science and about outcomes and expected outcomes, how would Steve A, that followed your advice, live his life as he ages, and how would Steve B, how would his outcomes be as he ages? Like, what would you, if you had to, obviously this is like super, you're forecasting here and it's like hypothetical, but what do you think the variance in these two people's lives would be?
Well, if you're talking about the extreme ends, like if Steve B was like eating sugar and smoking and drinking and just obese and sedentary, everything that you don't want to.
Which is like a lot of the population.
Then you're talking like a 14-year difference in life expectancy, which is pretty big. But not just life expectancy, the way your independence, right? Your mind. So you'd be forgetful. It would be a terrible quality of life, right? So it's not only are you going to die earlier, you're just not going to live a good quality of life. So Steve A might be into his 90s and out surfing, because you've exercised, you've given your body like the right nutrients that it needs, you've gotten good sleep, you're not overweight, you're not eating a lot of refined sugar, all these things that sort of accelerate the aging process. And we can talk about different components of this and how they do affect the way we age and our disease risk. But there's studies that show even like a 14-year difference in life expectancy for like someone who's morbidly obese versus lean.
So Steve A could be out surfing at 90 and Steve B would be potentially dying at 75, but also his quality of life his health span would diminish probably in his 40s and 50s.
Right.
So it's a 14-year reduction in lifespan, but potentially a 30, 40-year reduction in health span.
in quality of life and health span, being able to be functionally independent, being able to be cognitively sharp, feel good, right? And your mood. I mean, all these things are affected.
You must be sitting on some crazy ideas, because as a biomedical science, you can kind of see, as a biomedical scientist, you can see some of the research and technology that's coming down the pipe. So I'm wondering, before we get into the conversation, are there any big ideas about the future of aging and longevity that are in your mind that you think about that are actually really important to know? Because as Brian Johnson has often said to me, you want to live to see these breakthroughs.
Yes. I am excited about some gene therapies and being able to sort of reprogram our cells to be more youthful. So, this is something that was pioneered back in 2006 by Shinya Yamanaka from Japan, and he actually won the Nobel Prize. Why his research was so important for the field of aging wasn't really known at that time. What he had shown is that you could take a cell that's old, and it could be any cell. It could be from an 85-year-old person with Parkinson's disease, for example. And you get it, we're constantly getting skin cells and sloughing them off every day. And you can take one of those cells and add 4 different proteins to them. They're called transcription factors. Essentially, all that means is they're kind of like master orchestrators of many different genes in your body and how genes are activated and turned on and doing what they're supposed to, or they're turned off and quiet for the time that they're supposed to be quiet. And it's you add those 4 proteins, and you can take that 85-year-old skin cell from a person with Parkinson's disease, and you can make it into what's called an embryonic stem cell. And it does that by sort of wiping out what's called epigenome. So people are familiar with their DNA, right? Well, the epigenome is something that sort of sits on top of your DNA, and it regulates, how your genes are being expressed or turned on and off, right? And it sort of brings it back, reprograms it to this youthful state where it becomes an embryonic stem cell. And then that embryonic stem cell can then form any type of cell in the body. It can form a heart cell or a liver cell or a brain cell or a cell from your eye. And so this is called induced pluripotent stem cells. And this was a breakthrough at the time because it was so important. It's important for cell regenerative therapies. Okay, let's say someone does have Parkinson's disease, and you want, Parkinson's disease people are losing dopaminergic neurons in their substantia nigra. So these are dopamine-producing neurons. And dopamine is important for motivation, and it plays a role in our, cognitive function, but it's also important for movement, right? So people with Parkinson's disease are losing those at a rapid rate, and they lose control of their motor capabilities. And so you want to be able to take an old skin cell from someone, reprogram it to become a dopamine neuron, and then inject it into that person, right? It's their own cell, so they're not going to reject it, right? So that was like the big thought at the time. Fast forward, a decade or so, and a whole handful of brilliant aging scientists have discovered that instead of taking these old cells and putting these 4 proteins on it to become this sort of stem cell, they can pulse it, just a quick little pulse.
What is a pulse? Like an electronic shock?
No, what I mean is it's just not incubated for as long of a time period. So it's a shorter time interval that you're putting these 4 different transcription factors on top of the cell that reprogram it, right? And the reason for the shorter time is that you don't want it to lose its cellular identity. Mm-hmm. So let's say it was a skin cell. You want it to stay a skin cell, not become an embryonic stem cell. But you want it to be a skin cell from a 1-year-old, not an 85-year-old. Mm-hmm. So the way to do that is what's called partial reprogramming. And so researchers have found that you can just sort of, what I call pulse, is partial reprogramming. You're kind of putting it on for like a shorter period of time. And then that cell keeps its identity, but it's youthful. It wipes out all the damage, everything that's accumulated over those 85 years. And this has been shown in animal studies, in rodents, that if you add these 4 different transcription factors and you give them to mice, you can rejuvenate many of the different organs. So essentially turning back the aging clock in different organs in these mice. Now, this obviously has to be translated to humans, but I think it's super exciting, and I do think it's the future in terms of solving aging and rejuvenating our organs. And so it's something that I'm pretty excited about and following closely.
And are they then living longer?
Some of these studies were done in animals that are what's called accelerated aging. So yes, they were living longer in that background of accelerated aging. The question is, can they live longer if it's just a normal mouse that's not like an accelerated aging model? And these are things that are all being done right now. These sorts of studies are in progress.
Where do you think is the most important place for us to start this conversation, based on everything you know? And maybe presumably there's some like foundational stuff, right?
I do. I think the important place to start would be, we were talking about aging as a disease. And I think being sedentary is a disease. And I think that's a good place to start. What I mean by being sedentary is not physically active, someone who doesn't engage in any type of physical activity.
And what is the spectrum there of, someone who doesn't move at all for, 24 hours a day versus, or you've got obviously someone that's constantly running marathons and doing crazy stuff. But where are most of us on that scale? And are we moving enough?
Most of us are not moving on that enough. And most of us are, if you're talking about globally, we're on that sedentary scale where we're just not physically active. We sit at our computer or our desk or a cubicle, all day, and we're not actually moving around a lot. And I say sedentaryism is a disease because it's actually been shown to increase the risk of early mortality even more than diseases that we know of, like type 2 diabetes, cardiovascular disease, or even terrible habits like smoking. So being sedentary actually could predict early mortality even more than those diseases. But let's take a step back. It's even bigger than that. There's this amazing study. It's called the Dallas Bed Rest Study. And the study started back in the 1960s. And this is done by probably the world's most talented cardiovascular exercise physiologists. And so Ben Saltine, Jared Mitchell were involved in this early study in the 1960s. And what they did was they took 5 men, they were college students, and they put them on bed rest. And this is like 3 weeks of legitimate bed rest. We're talking they couldn't get up to go to the bathroom, so they had a catheter in them. They did not move for 3 weeks. The researchers wanted to find out what happens to your cardiovascular system if you are not moving around for 3 weeks. And now if you think about it, there's a lot of people that are undergoing surgery or they have some sort of bad illness, influenza or something that keeps them bedridden for, it's not unusual to be 3 weeks, to be honest. So it's not completely irrelevant. And what was found is after that 3 weeks, their cardiovascular system was just tanked. And one of the major, they were probably some of the most well-studied men at the time. And one of the biggest factors that was measured was their cardiorespiratory fitness. This is often called VO2 max. And essentially, it's the maximum amount of oxygen that you can breathe in your lungs, then breathe that oxygen to your muscles. And it's measured during maximal exercise. You're putting in a maximal effort. And that's called your cardiorespiratory fitness. And we can talk a little bit more about that. But their cardiorespiratory fitness tanked. And now, I mentioned this was in the 1960s. About 30 years later, and this is where Ben Levine came into the study. He's at the UT Southwestern in Dallas. He's also one of the most famous, cardiovascular exercise physiologists out there right now. They found these 5 men from 30 years earlier. And they measured their cardiorespiratory fitness and a variety of other parameters that they had measured at the time. And what they found was that 3 weeks of bed rest was worse on their cardiorespiratory fitness than 30 years of aging. So essentially, their cardiorespiratory fitness was no worse 30 years later than it was after their 3 weeks of bed rest, which is kind of amazing because you would think that the 30 years of aging would be worse on your cardiorespiratory fitness than the 3 weeks of bed rest.
And it's the same individuals.
The same individuals, the same 5 men. Now, after the 3 weeks of bed rest, back in the 1960s, they were able to get their cardiorespiratory fitness back up again once they started exercising and moving around, and it took a while. But when you look at their baseline levels, their baseline cardiorespiratory fitness, and you compare it to their cardiorespiratory fitness baseline 30 years later, it wasn't worse than what happened when they compared it to the 3 weeks of bed rest. And you might go, well, why is that so significant, the cardiorespiratory fitness dropping? We know that cardiorespiratory fitness is one of the best predictors of longevity. So there are studies that have shown that people with a high cardiorespiratory fitness live 5 years longer than people with a low cardiorespiratory fitness. That's, pretty big difference. They're basically 80% less likely to die of many different causes of death, so cardiovascular disease, cancer, respiratory disease, things like that, than people with a low cardiorespiratory fitness. So you're really getting, a 5-year increased life expectancy. You're sort of pushing and delaying those age-related diseases like cardiovascular disease, like cancer, for example. You're pushing them down later in life. So you're not dying from them sooner. And we do know that really just getting anywhere out of that low cardiorespiratory fitness. So people with the low cardiorespiratory fitness are people that are sedentary. And if you just move anywhere above that, even if you're going from low bad to like low normal, you're gaining about 2 years increase in life expectancy. And that's not really that hard to do. But if you think about cardiorespiratory fitness, like right here, just having this conversation, actually even just sitting quietly, it takes about 3 milliliters of oxygen per minute per kilogram body weight to do that. To carry groceries to your car, it takes about 11 milliliters of oxygen per minute per kilogram body weight. Mm-hmm. And so as you're aging, you're kind of heading towards this cliff, right? Because your cardiorespiratory fitness goes down with age. It does. That's what happens naturally. If you're at the point where you don't work on your cardiorespiratory fitness, if you're not being physically active, and there are certain exercises that are better at improving cardiorespiratory fitness than others, if you're not trying to improve it, you're going to be heading towards that cliff faster. And then everything becomes a maximal effort. You're out of breath just talking. You're out of breath carrying groceries to your car. Everything is a maximal effort, and you don't want to be there. That quality of life is not good. It's not good, right? And then on top of that, you're also going to die sooner. So you're talking about 2 things here. You're talking about decreased health span and decreased lifespan.
So yeah, we should be moving more.
Right. And the question is, well, how do you improve your cardiorespiratory fitness, right?
Yeah.
I mean, do you lift weights? Do you go for runs? Do you bike? What is it that is really good at improving cardiorespiratory fitness? And that's the question that a lot of exercise physiologists have answered over the last couple of decades. You want to do and engage in what's called vigorous intensity exercise. So this is the kind of exercise where you're not able to have a conversation when you're engaged in it, right? So your heart rate is going up to about 80% your max heart rate. You're not able to really talk. And I would say, it's something that can be done in intervals. So you can do high intensity interval training. So you have these intervals where you're getting your heart rate up, you're doing vigorous exercise, and then you have recovery periods where you're kind of resting, you're lowering your heart rate, you're not doing that maximal sort of exercise. And I say this because there have been multiple studies, that have shown people that engage in moderate intensity exercise. So this is the kind of exercise when you're breathy, but you can still kind of have somewhat of a conversation while you're doing it.
Like the Stairmaster.
Like the Stairmaster, yeah, exactly. Even people that are engaging in that type of exercise for 2.5 hours a week, so this is following the physical activity guidelines, 40% of those people can't improve their cardiorespiratory fitness. And it's like, well, I don't know about you, but like, I don't want it to be a coin toss in terms of like, if I'm doing that kind of exercise, well, if I have a 50% chance of not improving my cardiorespiratory fitness if I'm doing this, I want the sure thing. And the sure thing is you take those people and then you have them engage in high intensity interval training and they're able to improve their cardiorespiratory fitness. And that's because you're putting a stronger stress on your cardiovascular system. And so the adaptations are greater. And part of the adaptations are you're able to bring in more oxygen, carry it to your muscles, carry it to your other tissues better. And so that's your cardiorespiratory fitness. And so that's really, I would say, the bottom line here is engaging in even just once or twice a week. And I would say that the most well-researched protocol for that would be something called the Norwegian 4x4. And that is where you're doing a longer interval. It's a 4-minute interval, and it's best done on either a stationary bike or maybe a rowing machine. And you're going as hard as you can and maintain that intensity for 4 minutes. And then you're going to go down to light exercise and recover for 4 minutes and let your heart rate go down. And you do that 4 times. So it's a 4x4. And that is probably one of the most robust ways to improve cardiorespiratory fitness. But there are other ways, even doing, 1 minute on, 1 minute off. So you do 1 minute as hard as you can go, again, for that entire minute. You're not going all out, but as hard as you can and maintain that for the entire minute. And then you rest a minute and you do that, 10 times. So it's a 20-minute workout.
So for the several million people that are listening right now, if you had to prescribe them all something to do, and it was the minimum they had to do, tell me what exactly the workout would look like and how frequent it would be on a weekly basis.
I would say the minimum effective dose would be once a week.
Okay.
And it would probably be the 1 minute on, 1 minute off. If you want like the upper end robust effects of improving cardiorespiratory fitness, you can still improve it with something like a Tabata.
What's a Tabata?
Where you're doing a 20-second interval and you're going more all out because it's shorter time. And then you're recovering for 10 seconds. So it's a 20-second on, 10-second off. You do that 8 times. And if you repeat that twice, so it's essentially a 10-minute workout. That's also something that can improve cardiorespiratory fitness. But I would say, and I'll tell you why there's the minimum, right? So the 1 minute on, 1 minute off. But I would say the Norwegian 4x4 is the gold standard. And that's because it's not only improving cardiorespiratory fitness. This is probably one of the most exciting pieces of evidence I've seen with respect to, exercise and aging. And that is that being part of an exercise protocol was shown to reverse the structural changes that occur with age in the heart by 20 years. So, what do I mean by that? I mean, people that were 50 years old that were sedentary, so they weren't really going to the gym, they weren't engaging in any sort of physical activity, but they weren't, they didn't have diseases. They didn't have type 2 diabetes. They didn't have cardiovascular disease. I would argue being sedentary is a disease, but putting that aside, they didn't have any diseases, right? And they're 50, so they're midlife. And this was done by Ben Levine out of UT Southwest in Dallas. He took these, 50-year-olds and put them on a pretty intense exercise routine for 2 years, or a stretching routine. This was like the control. And this type of exercise routine was progressive. So they started out lighter and sort of worked their way up, right? Like you don't want to just start with the Norwegian 4x4, people that never exercise. I mean, that's going to be tough. So it was a progressive sort of building up to that. But towards the ends of about the first 6 months, these people were exercising about 5 to 6 hours a week. And that included 1 to 2 sessions of the Norwegian 4x4. And it also included a lot of, they're doing moderate to vigorous intensity cycling or running and some strength training as well. And they did this for 2 years. Their hearts were looked at. And so as we age, our hearts shrink and they get stiffer. And that plays a role in causing cardiovascular disease. I mean, that's the number 1 killer in the United States. It also affects cardiorespiratory fitness, right? Why does the heart, stiffen with time? Well, it has a lot to do with actually being exposed to a lot of glucose. When you're eating a lot of refined sugar and refined carbohydrates, you're having a lot of glucose around in your system. This causes a chemical reaction called glycation. So you get these advanced glycation end products that sort of react with your collagen that's lining your heart, your myocardium, and it causes it to stiffen. And so now the heart can't really respond to stress well. It's stiff. And that plays a role in like heart attacks, for example. So exercise is one of the best things you can do to move glucose out of your vascular system and get it to your muscles. And so that's one of the things that it does and helps with not causing that stiffening of the heart. And so essentially these 50-year-olds had their heart, the structure, so it was bigger and less stiff after 2 years of this, exercise protocol. It essentially made their hearts look like 30-year-olds. And I mentioned they were 50-year-olds. I mean, that's amazing. That's incredible that you can take someone midlife, put them on a 2-year training protocol, and reverse the aging of their heart by 20 years.
So on this Norwegian 4x4, you've convinced me to give it a shot. But specifically how I do that, so it's I do my warm-up, and then I do 4 minutes of hard exercise. I take a break, and the exercise I'm doing in those 4 minutes can be any number of things, but I just have to get up to 80% of my exertion levels, 80% difficulty.
So the way it works is, as I mentioned, it's best if you're doing a cardiovascular type of exercise. So like
the assault bike.
You could do assault bike. Yep, assault bike. You can do a rowing machine. You could do a stationary cycling machine as well.
Could I run?
You can, but that it's definitely I think it's better on doing like maybe a bike or assault bike or something. But you can run, like whatever it is that you like to do, and you are going as hard as you can for that 4 minutes and maintain within that 4 minutes. So it's not an all out, or it's far from all out, right? But you're not really having a conversation while you're doing it. And then the 4 minutes of recovery, if you're running, you kind of go down to walking. If you're on the rowing machine or the assault bike, you're just going very slow. You're just really going slow, and you're letting your heart rate come down. You're letting your muscles kind of recover, your cardiorespiratory fitness, kind of your cardiorespiratory fitness system recover somewhat. And then after that 4 minute recovery, you go back to the 4 minutes of like intense again. And you're doing that 4 times. It's not easy, but people can start out, even if you start out with not going super, super hard in those 4 minutes where maybe you can have a conversation, but you're still going harder than you're used to pushing yourself. And I think for people that haven't really engaged in any type of high intensity training before, that's a good idea where you can't just start doing it right out the gate. You want to kind of work your way up that. So doing the 4 minutes, to just try to put in as much effort as you can, right, during those 4 minutes. And then you do your recovery and you repeat that 4 times. But then work your way up as you do it 1 week, 2 weeks, a month later, 2 months later, and really try then to get to that point where during those 4 minutes, you're getting, you're pushing yourself hard where you're not really able to have that conversation.
And physiologically, what is going on in my body when I get to that 85, 90% effort range and I stay there for a couple of minutes that doesn't occur when I'm doing my Stairmaster?
I mean, so many things are happening. I mean, there's a lot of different, I would say, physiological responses that are...
You've got a big smile on your face when I ask that
Yes,
question.
I do, because it's, one of my favorite things to talk about. And it has to do with when you're pushing yourself really hard, you need to make energy, right? Mm-hmm. And the way that most of our cells make energy, like our muscles, is by using our mitochondria. These are tiny organelles inside of our cells that produce energy, but they need oxygen to do it. So that's where the oxygen comes into play. When you start to push yourself really hard, you can't get the oxygen to your muscles quick enough, but you need to make the energy. And so your body decides to make energy in the form of ATP without the mitochondria, and it uses glucose to do that. And you're not making as many of those ATP energy molecules, but you're still making them, and you're making them quick. And that's what your body wants to do. And so it's using glucose to do that without the mitochondria. But as a byproduct, it's making something called lactate. And this is what gets me so excited because, for the longest time, lactate was thought to be this just metabolic byproduct of glucose metabolism, where when you're pushing yourself really hard, anaerobic, it's called anaerobic. By the way, you're not only anaerobic. You're just somewhat anaerobic. You're still producing energy with your mitochondria. It's just you're also producing it without the mitochondria. It's not like a sort of black and white sort of thing, right? It's a little bit gray. Mm-hmm. But the reality is you're producing something called lactate. And for the longest time, it was thought this lactate, it's bad because, it can form lactic acid and that forms that burn in your muscles. And this was, decades ago. And we now know from the work of George Brooks out of UC Berkeley that lactate itself isn't causing the burn. And not only is it not causing the burn, it's like a miracle molecule that's being made. This metabolite, lactate, gets into your circulation and it gets consumed by your heart, by your brain, by your liver. And it's used for energy. It's very much similar to beta hydroxybutyrate, that ketone body that you always hear about people talk about when they're fasting or doing a ketogenic diet. It's actually very similar to that. It gets transported through the same transporter, and it's used like energy, very similar to that. But what's more exciting is that lactate is a way for your muscles to communicate with other organs like the brain. And it's called the signaling molecule. So it's your muscles are going, I'm working really hard. This is really hard. We have to respond to this work. We have to adapt. And so your body goes, okay, I got to like turn on all this awesome stuff that I have because I'm working so hard. I need to respond to that so that like I'm good, right? And so what happens is the lactate, this has been shown, it gets consumed a lot by the brain. And in the brain, it activates something called brain-derived neurotrophic factor, BDNF. And this is kind of like a miracle grow for your brain. So essentially, it's able to increase the growth of new neurons, which is amazing. It's called neurogenesis. It increases the connections between neurons, so it improves memory, cognition. And then it's involved in what's called neuroplasticity, so the ability of your brain to adapt to a changing environment. This is all from lactate. And it also increases neurotransmitters like norepinephrine, so focus and attention, serotonin, your mood, you're feeling better, you're motivated. All these things are happening because of lactate. And there's been studies in humans showing that people that are compared working out hard, vigorous exercise versus sort of moderate to light exercise, they make more lactate. And that lactate, it's been shown that high levels of lactate are correlated with improved cognition scores, improved impulse control. So serotonin plays a role in impulse control. So you're able to not just go on your impulse, right? You're able to kind of like, which is great if you want more focus and attention, right? So this is all really exciting stuff because it all comes down to just it's like your muscles are these little chemical pharmaceutical factories. And the way to make these pharmaceuticals is to work them, to challenge them. And that can be done with an easy high-intensity interval training protocol. A variety of them at Norwegian 4x4 can increase brain-derived neurotrophic factor. That's been shown. The 1 minute on, 1 minute off protocol also has been shown to increase that, again, through the lactate. So that's one of the big sort of, I would say, differences between vigorous intensity exercise and more of that moderate intensity or like low intensity exercise. And I honestly think, I think the guidelines, everyone's sort of obsessed with steps. I need to get my 10,000 steps in, my 10,000 steps. And they have wearable devices. And I think that's great. But I think we need to change the 10,000 steps to at least 10 minutes of vigorous intensity exercise. Like you could do 10 minutes of, any type of exercise that's really going to get your heart rate up. And it's going to be so much better.
So this is a really dumb question, but it's the question that I had in my mind, which is if lactate is such a miracle drug, why can't I just drink it? Why can't I just get a shot of lactate versus having to go through vigorous interval training?
It's a great question, Stephen, because there have been studies that have been done looking at, for example, traumatic brain injury patients, so people that have undergone some sort of head trauma. And they've infused sodium lactate through like an IV into their system, and the lactate immediately gets consumed by the brain. And it's been shown to improve their recovery. So it's called the Glasgow score. You may have heard of it, but it's kind of essentially this battery of tests that's done to sort of assess how someone's recovering from traumatic brain injury. And the sodium lactate does improve that. So you can find out there, different types of lactate that you can consume. Mm-hmm. And theoretically, it should help. But what happens is when you consume the lactate actually gets used by the gut. So a lot of it's going into the gut cells before it gets into your circulation.
There's always a trade-off with these bloody things. Whenever you try and trick the system or shortcut the system by like drinking something, I feel like there's a trade-off which people don't talk about a lot.
Well, the thing is that it is good for the gut. In fact, a former colleague of mine, Mark Chicanaga, has shown that lactate is really beneficial for the gut epithelial cells. And in fact, if you think about it, all these sort of beneficial probiotic bacteria, like bifidobacterium, for example, they're producing lactic acid. And that lactic acid does get converted into lactate. It's sort of like this physiological homeostasis where you have the difference of just a hydrogen atom. So you're having lactic acid and lactate sort of in this equilibrium, so to speak. But those bacteria in your gut are making lactate, essentially. And the reason it's so good is because it is a very easily utilizable source of energy for the gut cells. So not to go off on a tangent here. Yes, there is always a trade-off, especially for doing something orally. But when it comes to exercise, there's so, like I mentioned when we first started talking about exercise, if you could pill up what exercise does, it's so many things, right? It's not just the lactate.
Yeah.
So many different things, so many different adaptations that occur. I mean, it would be a miracle drug. So you're not just getting the lactate, you're getting the improvement in cardiorespiratory fitness, you're getting the muscular response, right? The adaptations to your muscle. You're increasing stress response genes like heat shock proteins that are important for preventing neurodegenerative disease. You're making antioxidants because the inflammation that you're generating while you're exercising. There's hundreds and hundreds of things that are happening all in concert from exercise. And you can't pill it up.
I have another really silly question, which is if lactate and these other things, even like creatine and all these other things are so good for me, why doesn't my body just make more of it?
I mean, your body does make it. The problem is that, as we're aging, everything becomes less efficient. Everything doesn't do what it used to do as well as it did when it was younger. And also in the case of creatine, which we can talk about, later if you're interested, then, your body only makes so much of it. And
why doesn't it make more? Maybe I'm not giving it the minerals or the environment it needs naturally to make more. I don't know.
You get it from your food too. Creatine is found in meat, in poultry, and fish. So probably that's why your body doesn't make more of it, because it knows you're going to be getting it from your diet as well. Mm-hmm. And so that is another way to get creatine.
Okay.
Of course, the vegans and the vegetarians, that's a whole other ballgame because they aren't eating meat. And so they're really essentially only relying on what their body can make.
We'll definitely talk about that later. On this point of the brain then, if I don't want to be an older person who can't remember things and stutters over my words and falls into cognitive decline. And I'm 32 now, so I feel like I'm at a moment in time where I can really make decisions now that have a really big impact on my 90-year-old brain and my ability to think straight and clearly and remember things. Are there things that I can be doing now that will have a profound impact on my cognitive performance at 90?
Yes.
And what are those things?
Absolutely. Well, first of all, just to kind of wrap up the exercise story, because I think this study is so profound. And in fact, it wasn't done in 32-year-olds. It was done in older adults. So we're talking 60-year-olds or a little bit older. And these individuals were put on a aerobic exercise training program for 1 year that was more of like a 70 to 75% max heart rate. So it wasn't so vigorous, but it was pretty vigorous for them, right? And the basis of this study was to look at brain aging. As we age, I mentioned our heart aging, right? It gets stiffer and shrinks with age. Our brain also shrinks with age. It's called atrophy. And as we age, especially starting in midlife, so around the age of 50, your brain and certain areas of the brain, like the hippocampus, which is involved in learning and memory, starts to shrink by about 1% to 2% per year.
I don't want that to happen.
Same. The good news is, in this study, after a year of this sort of aerobic exercise training program, they were doing 3 times a week, about 30 minutes a day, really not even that intense. These individuals, and then there was a control group that was kind of the stretching. They like to use the stretching as the control group. So let's talk about the control group, the stretching group. They did lose about 1% to 2% in terms of the size of the hippocampus. It shrunk 1% to 2% after that year, which is what you would expect normally. However, the group that was training, not only did they not have their hippocampus shrink by 1% to 2%, it actually grew by 1 to 2%, which comes down to that neurogenesis, that growth of new neurons, the brain-derived neurotrophic factor that's able to do that. You're actually able to grow new neurons even when you're in the age of 50, which is amazing. It's incredible. So that study I love because a couple of reasons. One, it shows that it's possible to not only stave off, some of the components of brain aging, but to reverse it and increase it, right, through exercise. And number two, I love it because it's never too late. Like you can start this, in your 60s and still have a benefit, right? You're talking about being in your 30s, but, some people watching the show, listening to the show may already be in their 50s or 60s, right? Mm-hmm. So it's never too late. Likewise, we're talking about being cognitively sharp and not getting dementia. There's also studies showing that people, like women that were brought into the lab, they had their cardiorespiratory fitness measured. Those women with the highest cardiorespiratory fitness were 80% less likely to come down with dementia over the follow-up period of time. So again, I think exercise is one of the big ones when it comes to brain aging. But you asked an important question. You say, what can I be doing now that's going to affect the way my brain ages, for the subsequent decades of my life? And there are other things that can also be done that don't even require as much effort as exercise. Exercise is the gold standard because, being able to not only, stave off atrophy of the brain, but to like regrow some of it is incredible, right? That's just mind-blowing.
Have they ever taken people with dementia, Alzheimer's, and put them on an exercise program and monitored the decline of their cognitive abilities on an exercise program?
Yes. It's much harder when you already have someone who is in that pathological state because things just really snowball and accelerate. And there are some benefits. But it's not prevention's always the best. Yeah. Prevention's always the best. And so, I think that if there's any sort of take home here, it's that like, let's try to do what we can now so that we don't get to that point.
Before we get into the easier ways of staving off cognitive decline, do we know what causes dementia and Alzheimer's yet? Do we have any ideas? Because when they do the brain imaging, they can kind of see these plaques on the brain, they say, but...
there's a lot of different, it's multifactorial, which means there's a lot of different causes of dementia and Alzheimer's disease. So I would say you mentioned plaques, amyloid beta plaques. What happens is, that's the aggregation of a protein in our brain called amyloid that typically is cleared from our brain. And what happens is this abnormal, thing happens where you're not clearing the amyloid. And so it starts to kind of form these clumps and aggregates with the amyloid proteins that are not being cleared. And that essentially is happening outside of your neurons, but it's happening where the synapses are formed between neurons. And so what happens is it kind of disrupts the synaptic connection between neurons, which is essentially forming a memory. And so when you start to disrupt that connection, you lose not only the memories start to go away, but the whole purpose of the neuron is to kind of, one of the purposes is to form a memory. And so you start to neurons start to die, right, when they start to lose their purpose. Amyloid aggregation is linked to a lot of things. So, for example, I mentioned it being cleared when we sleep, particularly when we're in our deep sleep stage, slow wave sleep. That is something happens that's kind of incredible. It's called activation of the glymphatic system. So you've heard of the lymphatic system. Well, the glymphatic system is essentially this series of networks and almost like these highways and essentially roads and stuff all throughout the brain where you're squirting this cerebral spinal fluid throughout the brain and it's clearing away all the garbage, things like proteins that didn't get cleared, and it's sort of squirting them out and clearing them out through this glymphatic system. That glymphatic system is activated during sleep, and it's one of the reasons why people that don't get good sleep over the course of decades have a higher risk of Alzheimer's disease, is because they're getting these amyloid plaques built up in their brains. But there's other causes as well. So, for example, glucose metabolism is disrupted in the brains of Alzheimer's disease. You need glucose. Your neurons need glucose. And so essentially your brain isn't able to make energy correctly without the glucose getting into your brain. And so that's another sort of metabolic underlying cause of Alzheimer's disease, where you're essentially, it's thought to be where you're eating a lot of refined carbohydrates, refined sugars, and you're not exercising, and essentially you're disrupting the glucose metabolism in the brain as well as the whole body, right? So the brain and body are connected. But there's also genetic causes as well. And, some people have genes that can increase the risk of Alzheimer's disease because they're not able to clear amyloid as well, because they're not able to repair damage as well. So the blood-brain barrier, which is really important for filtering out toxic things from getting into the brain, it starts to break down. And that's one of the, I would say, early signs of Alzheimer's disease, is that breakdown of the blood-brain barrier. And that happens in people that have a genetic risk factor called ApoE4. You may have heard of this, but this is probably one of the biggest genetic risk factors for Alzheimer's disease. About 25% of the population has one copy of this gene. That increases the risk of Alzheimer's disease by twofold. If you have two copies of it, it increases the risk of Alzheimer's disease by tenfold.
So twofold being 200%?
Twofold being twice as much. Yeah, 200%. And tenfold being 1,000%, right? You're basically almost, it's pretty bad. And it's not like it's not your destiny to get the Alzheimer's disease if you have those genes. You can do things in your lifestyle that can sort of turn the table. So you're not essentially going to be getting that Alzheimer's disease, and a lot of different lifestyle factors like getting good sleep, like exercising, avoiding alcohol, avoiding smoking, not being overweight and obese. Like those affect your Alzheimer's disease risk. More importantly, if you have one of those genes, then you really have to be cognizant of those things, because if you have one of those, ApoE4 genes, then essentially your lifestyle matters even more than people that don't.
And you can do a test to figure out if you have those genes?
Yes. There's a variety of genetic testing services that can be done. Pretty much all the ones that are out there on the market, Ancestry DNA. Depending on where you live and there's so many out there right now that will test for that.
Mortified if I found out I had two of those genes.
Two of them is less common. When I mentioned the 25% of the population having it, it's usually one allele. Alcohol essentially can really increase the risk of Alzheimer's disease if you have one of those genes. And I think that there's really no safe amount of alcohol that can be consumed for people that have ApoE4 if you're concerned about dementia and Alzheimer's disease. The other thing is contact sports and traumatic brain injury. People that have any of the, any one or two of the ApoE4 genes, if they have that, then if they get a TBI, like if they're playing American football or they're playing soccer or MMA or boxing, whatever, then you talk about like going up to a tenfold risk for Alzheimer's disease when you get like an injury, because people with those genes don't repair damage as well. And so it affects their brain's ability to repair damage. And so that's also really important to consider.
So moving back then to the simple things that we can do to improve our cognitive performance as we age, the things that are simpler than doing the vigorous HIIT training.
There's actually quite a few. And first and foremost, the one I love the most is a simple multivitamin. And the reason I love this is because, it was about 10 years ago, there was a huge study that was published. And it was published in the Annals of Internal Medicine, and it was called Enough is Enough. Multivitamins are not only useless, they're harmful. And it was essentially looking at a variety of studies and arguing that multivitamins are expensive urine. You're just not really doing anything. And in fact, if you take a multivitamin, you might even be increasing the risk of disease. That study was terrible. And I, 10 years ago, went and just broke it down and, pulled it apart piece by piece. But here we are 10 years later, 3 large clinical trials have been done. These are randomized controlled trials where older adults were given either a multivitamin, and this was just your standard run-of-the-mill multivitamin, Centrum Silver, or they were given a placebo. And they were given this for a couple of years. And what 3 different studies showed was that a multivitamin improved cognition, improved processing speed, it improved what's called episodic memory. So the kind of memory where you're remembering experiences and you can recall events, things like that. And not only did it improved it so much that it was equivalent to reducing the aging of the episodic memory by 5 years. So a simple multivitamin. And why is that important? Because, multivitamins have a variety of these vitamins and minerals that we're not getting from our diet that are important for everything, for metabolism, for the way our neurotransmitters are firing, for reducing damage that's causing, oxidative stress, right? So a simple multivitamin, how much easier can it be than taking a simple multivitamin? And the fact of the matter is that we're talking about a randomized controlled trial. This is showing cause, right? This isn't just an association. This is showing that you took a multivitamin for a couple of years and it improved your cognition more than a placebo. Mm-hmm. So I think that's pretty incredible, and it's one of the examples that I like. But diving deeper into some of the nutrients, this is an area, I started out as a scientist. I started out as a chemist, actually. But when I first got into biology, I was working in an aging lab and studying aging. It was very interesting to me because I essentially, with my own experiments, with my own two hands, could manipulate these like tiny little worms. They're called C. elegans. And their whole genome was sequenced at the time. And this was like in the early 2000s. And they have a lot of genes that are similar to humans. It's called homology. And one of the genes is the insulin signaling pathway and the IGF-1 pathway. So insulin signaling would be something that's activated with glucose when you're eating a lot of sugar, right? And I could take these worms and I could genetically decrease their insulin signaling. So it kind of, if you think about a parallel to that, that would be, okay, we're not going to be eating as much sugar, right? We're not going to be activating that pathway so much. Mm-hmm. And I could do that in this worm that has a life expectancy of about 15 days. And I could extend its life expectancy to 30 days, right? So you're increasing its life expectancy by pretty much, 100%, right? Well, not only did they, live longer, they were healthier and youthful. And you could see that visually. They're moving around and they were just youthful worms. And so I was very excited about this, in my 20s, because I was like, wow, this is very relevant. We have this gene and we know lifestyle factors that affect it, right? Sugar. So the take home for me was lifestyle matters. Genetics. Maybe that'll be something one day where we're decreasing the insulin signaling. But I was looking for the now, not the future technology. And so the now to me was, wow, like I don't want to be constantly activating my, insulin signaling pathway. Like, look what happens to these worms if you reduce it. I mean, it's amazing. They're youthful and they live longer. And so I started to kind of get into diet and lifestyle sort of just out of curiosity and sort of reading in the literature. And I came across some studies from my mentor, Dr. Bruce Ames, where he was showing that not getting enough nutrients, like, for example, folate. Folate is found in dark leafy greens like kale. Folate, if you decrease folate and make someone deficient in it, it essentially causes double-stranded breaks in your DNA that essentially is like being under ionizing radiation. And that experiment was done. Like, you could take a mouse, make it like put low folate in the mouse's food, and then take another mouse and put it under an ionizing radiation machine. And the amount of double-stranded breaks in their DNA, which cause cancer, which accelerate aging, which affect every how your cells are functioning, it was the same. So it was like, wow, not having a certain nutrient in your diet was like standing under an irradiating machine, ionizing radiation. No one's going to want to stand under an ionizing radiation machine, but no one's thinking about how your diet can do the same thing. And that was kind of, I got into a lot of Bruce's research at the time. So Bruce, anyone in the science field knows Dr. Bruce Ames. He actually came up with the Ames carcinogen test. And that essentially was a way of cheaply looking at and identifying whether something's a carcinogen. And he got into sort of nutrition as he started to figure things like folate, basically lack of folate being a carcinogen, essentially, right? Like ionizing radiation is a carcinogen. And then he started to go on to other nutrients as well, like magnesium and B vitamins. But I think for me, the aha moment was micronutrients and these vitamins and minerals are affecting the way we age are affecting our health on a similar level as these toxic things that we're worried about, like ionizing radiation. And nobody's thinking about it like that. So I'll give you an example. Vitamin D, you talked about dementia, what's going to help prevent dementia. Vitamin D it's actually more than a vitamin. Vitamin D gets converted into a steroid hormone. So a steroid hormone, essentially, what it does is it goes into the nucleus of a cell where all your DNA is, and it's activating genes and deactivating them. It's affecting your genome. And it's actually over 5% of your genome is being affected by vitamin D. Why is that important? Because 70% of the US population has insufficient levels of vitamin D. The reason for that is because vitamin D3 is actually made in the skin from UVB radiation from the sun. And so if you're not outside, then you're not really making a lot of vitamin D3 in your skin. And vitamin D3 then gets converted into this steroid hormone that regulates everything, right? And so, in modern day society, we're inside all the time. We're working. We're not outside. And even if you were outside, there's so many other factors that affect it. So anything that blocks out UVB radiation blocks out the ability of your body to make vitamin D3. So sunscreen, right? That's a big one. Melanin, the darker pigmentation that acts as a natural sunscreen. And then latitude, depending on where you live also. So, a good number of months out of the year, if you're in a more northern latitude, like England, like Wales, like Chicago or Sweden, UVB radiation's not even hitting the atmosphere, for several months out of the year. Combine that with sunscreen or melanin, and you got like this disaster, right? In fact, there was a study out of the University of Chicago that looked at African Americans and Caucasians and their
Black
ability.
people and white people.
Yeah, exactly. Their ability to make vitamin D3 from UVB radiation.
From the sun, yeah.
And as I mentioned, melanin is a natural sunscreen. And, people that are, either, from African origin or South American or Southeast Asian, right? People that are closer to the equator usually have more melanin. It's an adaptation to prevent you from burning from the UV rays of the sun. Well, this University of Chicago study found that, people that are African American had to stay in the sun 6 to 10 times longer than people with fair skin, the Caucasians, to make the same amount of vitamin D3. And so as a consequence, if you take someone who, like yourself, well, you got a little bit more melanin.
I'm like mixed.
A little bit, yeah. You've got a little bit more melanin. But let's say you take someone who, has
like my mom. She's Nigerian.
Okay, your mom Nigerian. And let's say your mom moves to Chicago, right?
Well, she's moved to bloody England.
Or if she moved to England, right, exactly. Then you're talking about a recipe for disaster in terms of vitamin D, because you're not only not making it several months out of the year, I forgot how many months out of the year, maybe 4 or 5 or something like that, where the UVB radiation is not even hitting the atmosphere, but you have this natural sunscreen.
What's the consequences of that in terms of symptoms?
Well, it's not like an acute thing where you kind of just look in the mirror and you're like...
But what is the causation then in terms of...
Right. Yeah. So the reason I say this is because people always think of like, well, I'm not getting enough vitamin C and I have scurvy, and you can look in the mirror and your gums are falling apart, right? It's easy to identify this. Vitamin D deficiency or insufficiency is more insidious. It's kind of this damage that accumulates over time. It's something that isn't, quite noticeable, or maybe you're feeling, maybe you're feeling like lethargic, or you don't have enough energy, things like that, but you don't really know quite why. So vitamin D insufficiency and deficiency, there are acute effects where, like, if it's severe, it can cause rickets and like bone malformations and stuff, especially if it's happening early in life. But what we now know is that being deficient or insufficient in vitamin D can increase dementia risk by 80%. And that's been shown in multiple studies. The converse is also true. So people that supplement with vitamin D3, and this is where a simple solution comes in, right? So you're not making it from your skin, but you can take a supplement. People that supplement with vitamin D3 have a 40% reduced risk of dementia. So in other words, they're avoiding deficiency, which is very common. And avoiding that deficiency then is reducing their dementia risk. And there's actually even been studies in people with dementia and people with Alzheimer's disease that were giving a vitamin D supplement or a placebo control. And those individuals given the vitamin D supplement had improved cognition. They had lower markers of amyloid plaques. So those were also measured as well. So vitamin D is doing a lot of things. It's regulating 5% of your protein-encoding human genome.
If I want to increase my probability of getting dementia, then I've got to stay out of the sun. I've got to avoid vitamin D. I've got to drink alcohol, smoke, be sedentary, and I've got to sleep really badly.
Yes, and eat a lot of refined sugar.
Yeah.
Yes, exactly.
Okay.
Exactly. Now, you might go, well, how much vitamin D, right? I'm talking about deficiency and insufficiency, and you really want to get a blood test to know what your levels are. There have been, 30 plus studies that have looked at vitamin D levels and all-cause mortality. So that would be, again, how, dying from a variety of different diseases, cardiovascular disease, respiratory disease, cancer. And people that have blood levels of vitamin D between 40, 60, maybe 80 nanograms per milliliter have the lowest all-cause mortality. So these people are not deficient, not insufficient. Insufficiency happens at about 30 nanograms per milliliter. Below that, deficiency is 20 nanograms per milliliter and below. And so there have been a variety of studies that have looked at, for example, the brain and the aging brain and vitamin D levels. And it's been shown that for every 10 nanomole per liter decrease in vitamin D blood levels, there's an increase in brain damage. It's called white matter hyperintensities. It's basically damage to the white matter in your brain. And the white matter in your brain is myelin. That's how your brain's communicating and like how, electrical impulses are being, moved so that you can think and talk and all that. Exactly.
Yeah, I hadn't had one today, so I feel like you've persuaded me.
Most people that are deficient can increase their blood levels to a normal sufficient level by about 4,000 IUs of vitamin D per day. So that's been done. That's been shown in multiple studies. It's not that hard to take. In fact, vitamin D supplements are probably the cheapest supplement out there. It's like 10 cents per pill.
When you talked about these, I was really surprised to hear that they have cancer-preventing chemicals in them. And then I was looking at some of the research, and it does say, exactly as you said, things like kale, broccoli, Brussels sprouts are linked to a reduction in breast cancer risk, prostate, lung, and colorectal cancers, according to the World Cancer Research Fund and PubMed. Most of us don't eat enough of this stuff because it's not the tastiest stuff. And you talked about sugar as well. It makes me think about the diet that I'm currently on, which is the ketogenic diet, and whether that is an optimal diet in terms of all of the things we've discussed earlier: dementia, longevity, aging. What is your views on the ketogenic diet?
I think there's the extreme ketogenic diet, like the classical ketogenic diet, and then there's modified sort of low-carb ketogenic diets that do allow for, these are leafy greens that are carbohydrate, but they're high in fiber and they're low glycemic index. And so you can actually eat leafy greens on a ketogenic diet and still be in ketosis. So the ketogenic diet I'm very interested in it because I do think that beta-hydroxybutyrate, which is the major circulating ketone body that's produced when you're in ketosis, is highly beneficial, much like lactate. It can actually do a lot of what lactate can do. It gets into the brain, and it's an easily utilizable source of energy by neurons.
These are ketones, which is what your body makes when you abstain from carbohydrates and sugars.
Yes.
It eventually shifts into ketosis, where you're running on you're in ketosis and you're running on ketones.
Yes. It's what you're measuring when you're measuring your finger prick. It's beta-hydroxybutyrate. That's the major circulating one that you're measuring, and that's actually a signaling molecule. It's activating brain-derived neurotrophic factor in the brain. And so it's very interesting because it's almost like having lactate in your body, but having it constantly. So I'm super interested in a ketogenic diet, particularly for people that respond well. Some people, their triglycerides go really high, their cholesterol goes really high, and there's sort of I would say, individual variation in terms of how you respond. And so it's good to always measure everything, right, to make sure that you're responding well to a ketogenic diet or to maybe cycle it. I've been very interested in cycling it for brain benefits as well because of the beta hydroxybutyrate, where it's just so beneficial for the brain. It's been shown that, beta hydroxybutyrate. So what happens is when you have this ketone, like beta hydroxybutyrate, get into the brain, it's able to be used as energy instead of glucose.
I feel like we should take a step back and explain what keto is for the listener who maybe has never really heard or understood it before. And I know that there's a large proportion of people that don't know what it is, because I spend a lot of time at dinner parties trying to talk about it, and it's super surprising to me that the average person actually doesn't really know what keto or ketosis is.
So I think that's great. Yeah, we can talk about ketosis. Essentially, if we kind of take a 1,000-mile high view of it without getting so technical,
yeah,
I would say the best way to think about being in ketosis is your body is using fatty acids as energy and not much glucose. You'll still use a little bit of glucose. You need to use glucose because your red blood cells, for example, don't have any mitochondria. They need glucose. But you're mostly using fatty acids as energy that are being they're being released from fat stored in adipose tissue.
Which is like my belly.
Which is like your belly, visceral fat, subcutaneous fat.
So this sounds great. My body's going to burn the fat instead of burning glucose, which I've got from eating bread or something. So I'm going to get skinny.
People do lose weight on a ketogenic diet.
My dad has lost so much weight. It's ridiculous. It's like shocking.
On a ketogenic diet?
Yeah, it's crazy. He was quite a big man, if I say so myself. Very big belly. And he sent me the screenshot the other day after a couple of months on the ketogenic diet. And he's like 13. He's just, for the first time ever, been 13 stone since he was in his teens. He's now 13 stone. So he's lost what the equivalent of about 4 or 5 stone in weight in a couple of months, and he just looks completely different. Now, I'm not necessarily saying to stay on that diet forever, but the speed in which one can lose weight on a ketogenic diet is remarkable.
Right, and so you're basically, the food that you're eating is predominantly fat, right? So you're basically not only using the fat that your body already has stored, but you're also fueling yourself. You're feeding yourself more fat, right? So you're basically using the fat as energy, and through a whole bunch of biochemical reactions, you produce ketone bodies as a byproduct of that. It doesn't necessarily have to be just ketogenic diet. Like you can, when you're fasting, you go into ketosis, right? Because if you think about it, you're not giving yourself food. Instead, you're relying on what your body already has as a source of energy. And you only have so much glucose stored as glycogen, right, in your liver. And that, I would say, there's individual variation, but after about 12 hours of not giving your body food, you sort of deplete all your glycogen stores. And then so you start to shift to lipolysis, which means the breakdown of fat. So fasting is another way to get into ketosis. Another way would be intense exercise. So like, these endurance athletes that are doing long duration types of exercise also can go into ketosis, right? Because they're depleting their glycogen stores much quicker, and they're also using all this energy that they've fueled themselves with because it's so intense, right? Long duration type of exercise. And you can combine these things as well, right? You can do endurance exercise with a ketogenic diet, and you really kind of can get into ketosis quicker.
Is it like a switch?
So there is something called metabolic flexibility, which essentially means that your body is able to switch between burning glucose and using glucose as energy, but also using fatty acids as as energy, and then producing ketones as well. And the more, if you've done ketosis, or if you exercise a lot, like frequently, or you do any form of fasting or what's called time-restricted eating. So let's say you eat all your food within an 8-hour window, and then for 16 hours, you're not eating food. Your body is used to switching to fatty acid metabolism, to using fatty acids as energy. So you're really metabolically flexible. And not everyone's able to do that, because most people actually, they think they eat within a 12-hour period, but there's been studies that have been done that have shown that actually they eat more like within a 15 to 16-hour period, not even a 12-hour period, certainly not a 10 or 8-hour period. So there's, as I mentioned, it takes about 12 hours on average to deplete all your glycogen levels. Now you can accelerate that if you're doing a lot of physical activity. But once you deplete that liver glycogen, that is when you shift into burning fatty acids and then eventually ketosis, right?
In terms of longevity, have they ever done any studies where they've put someone on the ketogenic diet or like a mouse or a rat on the ketogenic diet versus the average diet and then monitored how long they live?
There have been studies by Dr. Eric Verdin out of the Buck Institute for Aging in Novato, California. And I mean, this was several years ago. He's done these studies probably almost 10 years ago, maybe about 2018 or 2017, these studies were published. But he did do some of these studies with a ketogenic diet in rodents. And it did seem to extend life expectancy, but more importantly, the health span. So particularly in the brain. So it's like their brain had aged much, much better. They had less of all of the pathological features of Alzheimer's disease. Mm-hmm. And again, I do think, like I mentioned, I'm super interested in beta hydroxybutyrate in particular. I mean, it's multifactorial because on the one hand, you're not eating as much glucose, right? And that in and of itself is important because glucose can be so damaging, particularly if you're not physically active. Because it's not, if you're physically active and you're eating some amount of glucose, it's going into your muscle. Yeah. It's not damaging the vascular system. The vascular system is very much related to the brain, right? So when you start to stiffen your blood vessels and stiffen everything, I mean that's affecting blood flow to the brain. It's causing hypertension. That all affects brain aging as well. So I think just and then the damage that the glucose does in and of itself. Like I mean, there's studies. It's really interesting. There's studies showing that people, even on the high end of normal in terms of their blood glucose levels, so they're normal, but they're kind of on the high end of normal, they had more brain atrophy than people on the low end of normal.
By brain atrophy, you mean their brain was shrinking.
And it was the hippocampus, by the way. Again, that part of the brain that's involved in learning and memory. So the glucose itself has this effect on causing damage and accelerating the aging process. But then there's this other very interesting effect of these chemicals that are made as a byproduct of being in ketosis, and that is the beta hydroxybutyrate, that ketone body, gets into the brain. It's transported across the brain through an MCT transporter. And when it gets into the brain, it can be used as energy, and your neurons don't need to use glucose. And it can do that. So your neurons can use glucose as energy, but it takes energy to use that glucose to make energy. When you use the ketone, the beta hydroxybutyrate, it takes less energy to make that energy. So it's energetically favorable to actually use that ketone, that beta hydroxybutyrate. On top of that, this is what's so interesting, it frees up glucose. So the neurons aren't using the glucose. Where does the glucose go, right? Because it's there. It sort of shunts it into this other pathway that's called the pentose phosphate pathway. I don't want to, burden people with all this technical details, but let's get to the important part of that is that it shunts glucose into this pathway that makes, essentially it's precursors that make what's called glutathione, the major antioxidant in the brain. And so you're making more glutathione day after day after day. That is huge because oxidation in the brain, inflammation, this is a huge cause of brain aging and Alzheimer's disease, dementia. We now know neuroinflammation is one of the major causes of it. And so if you have more glutathione in your brain, you're going to basically sequester that damage that's causing, that's aging the brain, essentially. And so the glucose now is not being used for energy. It's being used to make an antioxidant in the brain. Okay, that's also really cool. And there's more. Okay, so then the beta hydroxybutyrate itself is a signaling molecule like lactate.
The ketone.
The ketone itself is a signaling molecule where it's basically, it's a little bit of a stressed state, right? So when you're in ketosis, you're stressing the body. It's either exercise or you're fasting or you're on this ketogenic diet. And so your body, again, is responding to that stress by making like a bunch of awesome, resilient stress response things that are basically going to improve the way you age. And so the ketone, beta hydroxybutyrate, then activates brain-derived neurotrophic factor, this miracle grow for your brain, right? It's involved in growing new neurons. It's involved in increasing the connection between neurons. It's involved in neuroplasticity, all those things. And so you get this multi-level benefit, not having the glucose causing the damage. You have basically the glucose now being used, not only is it not causing damage, it's being used to make an antioxidant. And then you have the whole ketone, aspect where you're essentially making and activating all these beneficial pathways in the brain that reduces aging.
And what's going on when we take exogenous ketones, external ketones via a drink or something like that?
Yeah, so what's happening is you're essentially giving your body the beta-hydroxybutyrate ketone that it would make normally if you were undergoing ketosis and using fatty acids only as energy. You're giving your body a big boost of it. So you're kind of bypassing the way that your body would make it itself and giving it to your body. And it's great for people that have a hard time with doing a ketogenic diet, for example. Maybe they just can't stick with it, or maybe they don't respond very well to it in terms of other biomarkers. They're going to get a lot of the benefit, but it's only going to last, 1 to 3 hours, right?
Yeah, until it flushes out, right?
Until you use it up. Yeah, and so it's in addition to just people that want to get that focus and attention, which is what both you and I have experienced when we've taken these, supplements, this exogenous ketone. There's also some potential therapeutic effects. So people that have mild cognitive decline, maybe like the first stages of dementia or Alzheimer's disease, can kind of perk up and perform better when they're given an exogenous ketone, this supplemental ketone, beta-hydroxybutyrate. There's not a lot of studies on it, but there's like a few case studies being like a single person is given it and they're followed and looked at, And it's very interesting.
I actually know that they're doing studies on exactly that at the moment, because I've spoken to a few of these companies and a few scientists that are in this field over the last couple of weeks, in fact, and they were saying that we're currently in the process of doing studies to see that if exogenous ketones, which are these ketone drinks or ketone shots, can repair your cognitive faculties. And is that via the process that you describe, where glucose is pushed into this other pathway?
Yes. So I think I'm aware of the same study because I've looked it up in the clinical trial, and what's being looked at after giving this exogenous beta-hydroxybutyrate, this supplemental ketone, in people with Alzheimer's disease, you can repair damage because, again, you are activating brain-derived neurotrophic factor, which can repair damage. It can grow new neurons. It can help with brain atrophy. It can strengthen connection between neurons. And then the glucose now is being shunted into that repair pathway, that glutathione's being activated. And that's able to, repair damage as well. So I'm excited to see the public, that study published. Mm-hmm. I would hypothesize that there's going to be beneficial effects and it's going to be pretty exciting, particularly because it is hard for some older adults to do a ketogenic diet. It's not the easiest thing to follow. I mean, you do have to be pretty disciplined. So this alternative to being able to supplement with something that can sort of, at least for the course of a couple of hours, do what being on a ketogenic diet can do is very exciting, right?
When you took the keto shot that you had at home, what did you experience? You said it was potent, it was powerful.
Yeah, it was like a nootropic effect, where when I mean nootropic effect, it's the kind of effect where you feel focused, your attention, your alertness is enhanced, you're sort of filtering out all the background noise in your brain, that sort of those little thoughts that pop in and distract you. And so you're more productive. And that was very noticeable. In fact, there was a time when I was like, before any podcast, I would take a shot of it. I want to do it. And it's kind of expensive, but it is. There's a lot of people that are using it now, and I think it's a better alternative to some other nootropics that are common right now, like nicotine, for example, which can really have a negative trade-off, but can do something similar. Whereas this is like, not only gives you that sort of cognitive enhancement, that brain pump, it also has like benefits for brain aging, right?
What are your superfoods? There must be foods of yours. Olive oil has become one of my superfoods. Just a food that I love to just put on as many things as I can because everybody tells me about these polyphenols, which are apparently amazing for you. But what are some of your sort of favorite superfoods that you try and consume that most people might not think of? So we talked about leafy greens. I guess that's one of them.
It is. Leafy greens, they're high in magnesium, and, magnesium's at the center of a chlorophyll molecule. Chlorophyll give plants their green color. Magnesium is very important for preventing damage to DNA and cancer. And, half the U.S. population doesn't get enough of it. They're high in a lot of different compounds. I mean, they're folate, vitamin K1. So you're getting a lot of these micronutrients that are important. So I do like dark leafy greens. I particularly like kale and broccoli because of something called sulforaphane, which is, sulforaphane itself is not in them, but a precursor. When you break the plant or you chew it, it makes sulforaphane. So there's an enzyme that gets activated that converts a precursor in these plants called glucoraphanin into sulforaphane. Sulforaphane also increases glutathione in the brain. It helps detoxify pollutants like benzene, bisphenol A, BPA as well. So I do like dark leafy greens of the cruciferous family of vegetables. Again, that would be kale, broccoli. Those are the cruciferous family. I also like blueberries. Blueberries are a source of polyphenols. You mentioned olive oil as a polyphenol. If you're on a ketogenic diet, olive oil is like the great, right? Because you need fat. And olive oil is so great because it also has those polyphenols that are beneficial, and it's been shown even in studies to improve cognition and memory and lower even markers of bad cardiovascular disease, like ApoB, for example, lower that. So blueberries I like because blueberries have also been shown, even a cup of blueberries a day has been shown to improve cognition. So I like the polyphenols. It increases blood flow to the brain. I also like salmon, and I think that would be something that most people would think is healthy. I like it because it's high in the omega-3 fatty acids, which I'm very, very, I think it's very, very important to get enough omega-3 fatty acids. I also supplement with them because there's a lot of research out there, and if you want to get into that, we can. But the superfood would be the salmon because it is a fatty source of fish that is high in omega-3 fatty acids, EPA and DHA, which are found in marine sources, not plant sources of omega-3.
I found it really interesting when I was looking at omega-3 that it has an impact on mental health and depression and things like that.
Yeah, it does. It resolves inflammation. It's sort of an anti-inflammatory, and inflammation plays a role in depression, a big role. In fact, we know that people that are injected with inflammatory molecules, like something that's made in our gut from the bacteria in our gut called lipopolysaccharide, if you inject them with that, or a placebo control, which is saline, it causes depression. But if you give them an omega-3 fatty acid supplement, EPA, it blunts the depressive symptoms. So in other words, if you're causing the inflammation by injecting something that causes inflammation in people, it causes depression. But if you give those same people something that blunts that inflammation, omega-3 fatty acids, it doesn't cause the depression, which is kind of amazing. And there's a ton of other evidence out there. But omega-3 fatty acids they're so important. And what's interesting was there's a study out of Harvard that identified the marine source. So I talked about salmon, EPA, DHA, and then there's the plant source, ALA. And I say marine source because those are the important ones that you really want.
From the ocean?
From fish, seafood. So this Harvard study identified not eating enough seafood as one of the top 6 preventable causes of death, up there with not having hypertension, not smoking. So essentially, not getting enough omega-3 from seafood was so important for preventing early death that it was comparable to people having high blood pressure, having cardiovascular disease, for example. And again, it's one of those things where people just don't think about what they're not eating, what they're not getting. And there's so much research that have been done even since that study that was published in 2009, looking at omega-3 fatty acid levels in our blood cells, red blood cells. This is called the omega-3 index. It's really an important marker of our long-term omega-3 because our red blood cells stay around in our system for 120 days. So it's a long-term marker of your omega-3 intake. And there's been a variety of studies done from Dr. Bill Harris out of the Fatty Acid Research Institute. So I'm an associate scientist there, showing that people with what's called a high omega-3 index,
Which is a lot of omega-3.
A lot of omega-3. Their omega-3 index would be 8% or higher. That's considered high. Compared to a low omega-3 index, that would be 4% or lower. The average omega-3 index in the United States is about 5%, so it's on the low range. People that had the high omega-3 index, in other words, they were either eating a lot of fish, like salmon, and or supplementing with fish oil or microalgae oil, which is a marine source of these omega-3 fatty acids. They had a 5-year increased life expectancy compared to people with a low omega-3 index. Pretty big difference there. And all you have to do is essentially either eat enough seafood and or supplement with a fish oil supplement. But what was so fascinating about this study was that Bill and his colleagues not only looked at the omega-3 index, they looked at people that also smoked. And they said, okay, we know smoking is terrible for your heart. We know it causes early mortality, cancer, and all that, right? What about people that smoke and their omega-3 index? So there was 4 groups that were looked at. Smokers that have either a high omega-3 index. So these smokers were either supplementing or they were eating a lot of seafood. And then there were smokers with a low omega-3 index. And they compared them to non-smokers with a high omega-3 index versus a low omega-3 index. And what was so fascinating about this study was that smoking was like as bad for you in terms of mortality as having a low omega-3 index. So the smokers with a high omega-3 index had the same mortality risk as non-smokers with a low omega-3 index, which is fascinating because everybody knows to avoid smoking. Smoking, if you want to take years off your life, if you want to decrease the quality of your life, start smoking right now. But the same mortality risk was found in non-smokers who did not have a high omega-3 index, right? Now, I say this, I'll talk about this, and smokers will say, oh, great, now all I have to do is take fish oil and I'll have the same life expectancy as a non-smoker with, a low omega-3 index. But of course, the take home here is that for those of us that are not smoking, but we're not getting enough omega-3 from our diet, that's like smoking in terms of mortality risk. So super important. And I like talking about this because it really makes it, again, really clear that not getting these essential nutrients can be very detrimental to our health. And it's easy to fix. You can take a fish oil supplement. You can increase the amount of salmon that you're eating. And there have been studies from Bill's group that have shown people that supplement with between 1 to 2 grams of fish oil per day can go from a low omega-3 index to a high omega-3 index, which is not hard to do.
So I guess 2 questions, which is having these little omega capsules the same as eating the salmon in terms of the omega-3 that I'm getting? And how long do I have to take these little omega capsules for to move from having a low index to a high omega-3 index?
Well, these are great questions, Stephen. So essentially, this little capsule here is not the same as eating salmon. And there's a few reasons why. So for one, when you're eating a fish that's high in omega-3 like salmon, you have this omega-3 in what's called triglyceride form. So the omega-3 is bound to a glycerol backbone. And that's really important for the way you absorb it. Some fish oil supplements don't have that. They're basically molecular distilled, and then they have an ethanol backbone. So it's not quite as bioavailable. But I think more importantly is that these fish oil supplements are purified. So you're not getting mercury or microplastics or things that are also found in the whole fish.
So these are better?
Unfortunately, I think so. I do. As much as I think it's better, for the longest time, I was always a whole foods first approach. But we do have this environmental pollution problem. And fish have been contaminated with heavy metals. They've been contaminated with microplastics. I would say that salmon is one of the lowest fish that has the lowest amount of mercury compared to other fish. So on a per gram basis, you're getting less mercury per gram with salmon than you would be with, something like swordfish, for example. But you also have microplastics, unfortunately, that are now in fish. And it is something that enters our body when we eat the fish. And so I do think the fish oil supplements are a good alternative because you're getting those omega-3 fatty acids and you're not getting some of the other bad things that are in the fish.
That's fascinating. I didn't really think of omega-3 as being that important, especially as it relates to longevity. I always thought about it as being something that would help my brain work better today. Cognitive performance now.
Well, it does that. And it also helps prevent the cognitive decline later. And also cardiovascular disease. That's a big one. So there have been some really large randomized controlled trials that have actually given people with cardiovascular disease that are on, some sort of standard of care treatment like a statin. And they've given them 4 grams a day of a purified form of omega-3 called EPA versus a placebo. And the people given the omega-3 had 25% less cardiovascular related death or events like heart attacks and strokes. So it's not only like preventing, we talked about all-cause mortality and this association where you live longer. It's also helping people that already have cardiovascular disease and reducing their risk of dying from it.
When I asked you before this conversation started rolling, what you're really excited about at the moment, your response to me was, there was a few things, but one of them, which lit up your face, was creatine.
Yes. And it's funny because...
It lit up your face again.
Yeah, it's funny because creatine has been around for decades. And it's always been, in my mind, it was like one of those gym bro things. I'm like, I don't need to be swole.
Yeah.
I don't need creatine to get swole. And, this was the thought for many, many years. And then over the last 5 years or so, the effects of creatine on the brain started to really get my interest. Anything that affects the brain, I really become interested in. And so that's kind of what did get me the most excited about creatine. But also I started doing a lot of resistance training. And so I was like, okay, here I am now. I'm like one of those gym guys. I'm doing the barbells, I'm doing the squats and the deadlifts and all that. And so why not give myself some of the creatine? Well, what is creatine, right? Why is it important? You talked about earlier, why doesn't our body just make more of these things that are so beneficial? We do make creatine. We make about, our liver makes about 1 to 3 grams a day of creatine, and our brain also makes creatine, and those are the 2 organs that make it. Creatine gets consumed by other tissues, like the muscle is probably the one that's the greediest because creatine is stored as phosphocreatine, but it's used to make energy, essentially. So it can increase muscle mass, it can increase muscle strength in combination with resistance training because you're able to regenerate and make energy faster. So, for example, I became interested in it after reading studies where people that supplemented with creatine that were engaged in resistance training were able to gain more lean body mass, they were able to gain more strength. It was increasing their training volume. So you can do 1 to 2 more reps, right? Of whatever exercise you're doing. And it seems to decrease the recovery time between those sets as well. So you're able to increase your training volume. Well, anything that's going to increase your training volume is going to then have the downstream effect of increasing the adaptations like increased muscle mass or increased muscle strength. I started supplementing with creatine about a year ago, and I started supplementing with it for that reason, for my training. And I was doing about 5 grams a day because that was really what was shown to be beneficial for muscle health in combination with resistance training. And it's important for people to realize that supplementing with creatine by itself without any type of resistance training isn't going to grow your muscle. It's not going to make you stronger. You have to put in the effort because what creatine is doing, it's helping you make the energy quicker, right? And then being able to make that energy quicker means that you're able to then do that exercise better, harder, more of it, right? So it's sort of supercharging your exercise routine. And 5 grams a day was like, okay, perfect. That's what I'm doing. I'm doing 5 grams a day. And definitely noticed an effect on my training volume where I was, doing more reps. So that was like, okay, a year ago. I had already been aware of the effects on the brain. I thought maybe the 5 grams a day would do that. So what are the effects on the brain? Well, your brain also consumes a lot of energy, needs a lot of energy. So it does make its own creatine. But it turns out if you can give your brain more of that creatine particularly under a period of anything that's causing stress. So let's say lack of sleep, or let's say emotional, psychological stress, or in my case, high cognitive load, where you're just every day learning concepts, complex things, you're trying to remember them, you're putting ideas together and coming up with new hypotheses, and you're studying a lot, and it's very cognitively demanding, and it's a type of stress on your brain. That's like my life, right? Under this condition of stress, depression's another one. That's a stress on your brain. Or neurodegenerative disease, that's a stress on your brain. So any kind of stressful condition, that's where creatine shines in the brain. I would argue that, all of us, who has the perfect amount of sleep, never has stress? Nobody, right? There's always some sort of stress in the background. So that's when I was like, okay, so if you're the perfect person, you have no stress, you get the perfect amount of sleep every night, your brain makes enough creatine to kind of do what it needs to do. I know that I'm constantly under stress. So I'm like, okay, well, I think I need a boost. And this is where a lot of very interesting studies have come out of many different labs, some out of Germany that looked at the dose of creatine and how it increases creatine levels in the brain. And this is why I now supplement with 10 grams a day. So the study out of Germany found that 5 grams a day of creatine, if you're supplementing with 5 grams a day, your muscles are greedily consuming it, particularly if you're working out. They want it. After about 5 grams a day, especially over a few months, like you're saturating your muscle, and that's enough, right? Anything above that kind of spills over to the brain. And so what this German study found was that 10 grams of creatine increased creatine levels in several different regions of the brain. And that was probably the most exciting, I would say, evidence that supplementing higher than 5 grams a day was actually doing something in terms of getting creatine into the brain. There have now been a variety of studies that have looked at different outcomes, right? So if you supplement with 10 grams of creatine, or even go higher than that, like 20 grams of creatine, how does that affect cognitive function, right? And so some of these studies have been done by Dr. Darren Kandau. He's at the University of Regina in Canada. And they've looked at things like sleep deprivation. And it's been found that if you take someone and you sleep deprive them for 21 hours and give them about 25 to 30 grams of creatine, it completely negates the cognitive deficits of sleep deprivation. Actually, not only does it negate the cognitive deficits of sleep deprivation, it makes people function better than if they were well rested. That's where I was like, wait a minute. There's many times when I'm traveling, I'm jet lagged, lots of times when I'm sleep deprived and I have to be doing a podcast or a presentation, whatever. And in those situations, I go up from my 10 grams to more like 20 grams, like today, for example. I wasn't really sleep deprived, but, there was a lot of high cognitive demand. This is a long podcast. There's all that stuff. And so I went up to 20 grams today on my creatine. And I will say, even at the 10 grams, for me, we were talking about this with respect to being in ketosis. I don't feel that mid-afternoon crash when I have the creatine. Not being on a ketogenic diet, not being in ketosis. It's very clear for me, and I've done this, where sometimes I only do 5 grams, and then if I do that, I'll notice, I'm like, why am I tired right now? So there's something interesting, and maybe it's placebo. I'm going to throw that out there, very possible. But I don't know, maybe the creatine is, again, it's able to regenerate that energy quicker, and so that's also beneficial for the brain. And now I would say all these creatine researchers, a lot of them are shifting to the brain. It used to be all muscle focused. And now people are super interested in what creatine is doing to the brain, especially if you're supplementing with more of it. And, this is important for people that are under a stressful situation, but also for vegans, because creatine is found in food, mostly in animal products like meat and poultry and fish, dairy. A lot of vegans don't eat that. And I've had so many of my vegan friends, I've got them on the creatine and it's changed their lives. I mean, they're like, this is like incredible. Can you imagine someone who's not getting any creatine from their diet because they eat no meat, and all of a sudden they start supplementing with 5-10 grams of creatine, And it's like they have energy. Some people say they require less sleep, which is kind of interesting. That's kind of a comment I've heard many, many times from people, is that it's like their brain doesn't need as much sleep. They have more energy. So I've been a big fan of the creatine, not only for the muscle, especially because, working out is something that's very important, but for the brain as well.
I always thought of creatine as something that you took and you kind of had to load up on, and then over a couple of weeks or months, the effects would kick in. But you're telling me that if I had creatine in the morning, that same day, I would experience potentially improved cognition if I have a big enough dose?
Yes. So, great question. A lot of studies that have been done that you're referring to have been done in the context of exercise and muscular performance. And the reason why people have to load up on, like, they do a loading phase, let's say 20 grams, and then they go down to this sort of maintenance phase of 5 grams, is because it takes, I don't know, I think it's about a month or so before you can saturate your muscular stores of creatine. And then
what does that mean?
It means that the creatine, which is actually stored in your muscle as phosphocreatine, is there and ready to be used to make energy. So it takes, again, about a month or so to do that, unless you are really giving your muscles a high dose, right? So the 5 grams a day, it can only do it for so many days, and then finally you get saturated. When you do this loading phase, you kind of just accelerate that whole process. And so that's why when people are doing these experiments where they want to test the effects of creatine, they want the participants to have really high levels of creatine in their muscles quick, because they don't want to do a month-long experiment, right? They want the experiment to be like a couple of weeks or a week. So that was kind of the whole concept behind this loading phase. If you're not someone who's going to some kind of competition, like you're a CrossFit Games or something, you don't really need to do that loading phase if you've already been supplementing with 5 grams a day for like a month. When it comes to the brain, what's happening if you get above that 5 grams, that's pretty much all consumed by the muscle. You're having some left over in circulation, and the brain takes it up, and it takes it up, right? What it really shines is under that stressful condition, which, again, for me, I feel like every day is like cognitively demanding for me, because I'm constantly learning new material or learning new information or working on things, right? And so there's a lot of cognitive stress on my brain. And so I feel like I'm constantly under that stress. And that's where getting the creatine in your brain helps you make that energy quicker. And so that's why, like, I've had, been jet lagged and have to give a talk at, like 5 a.m. in the morning, my biological time after not getting sleep. And I've done like 25 grams of creatine, and it's insane how much it helps me. Again, it could be placebo because I'm anticipating that effect, which is fine. Placebo is a real thing. It's great. I'm all about it. But there's some evidence also that this works, right? That the creatine is helping with under that sleep deprivation and that stressful condition.
I was reading about a study in 2025 where they gave creatine to people that had depressive symptoms alongside CBT training. And the people that had creatine and the cognitive behavioral therapy training experienced a greater improvement in their depression symptoms than those who just received the cognitive behavioral therapy, which is incredible.
It's fascinating. I mean, depression is a type of brain stress, right? I mean, we know inflammation plays a role in depression. We know oxidative stress plays a role in depression. And there have now been some animal studies that have shown creatine is somehow having an anti-inflammatory effect. That hasn't all been worked out. So I don't know if it's all just the energy component of it. It could also be this other sort of newly identified role that creatine is playing in sort of having an anti-inflammatory effect. And I don't know enough about that. I don't know that there's enough even known about that, but I do know that it exists. And it's fascinating because, again, I think where creatine really shines in the brain, and it's been shown study after study, is under some kind of stressful condition, depression or sleep deprivation. Or there's a new study that came out. It was published, I don't know, a month ago or so, showing that it was a very small pilot study. And I want to caveat this. There was no placebo control. But it did show that giving people with Alzheimer's disease creatine, I believe it was 20 grams a day, did improve their cognition. And so, again, this is a whole new field where now we're looking at creatine in the brain, not just the gym bros and not just the muscular effects, but in the brain, and how it's affecting the brain and being beneficial for cognition, for brain aging, for depression.
Is there a link or an association with cancer outcomes in creatine? I was wondering, because there was a study that I was looking at earlier. Yeah, this one. It says a 2025 study of 25,000 people each found that for each additional 0.09 grams of creatine over a 2-day average was linked to a 14% reduction in cancer risk.
Right.
Which was in the Frontiers Journal and reported by the BBC.
Yeah, it's like a new unexplored, association here where it's like, I don't know why creatine is doing it. Is it the anti-inflammatory effect? Is it, who knows? But again, I mean, I was aware of that study, and it's like a whole new area that needs to be explored where, some people were worried about creatine actually causing cancer. I've actually had people ask me that question. And it's actually the opposite, where it seems to be reducing cancer risk.
Some of the other sort of misconceptions around creatine are that it's there was this stereotype that people take it, they get massive muscles and they become bloated. So I think that put a lot of women off in particular, according to some research that we actually did just to understand perceptions of creatine in my investment fund. But the other one was hair loss. People think there's some sort of association with hair loss, i.e. if you take creatine, you're more likely to lose your hair.
Right. So there was this one study that was published, I don't even know how many decades ago. Maybe you can pull it up. But it was in rugby players, I believe. And these rugby players that were given, I believe it was a high dose. Maybe it was 20 grams. I can't remember the exact dose. But they had increased levels of dihydrotestosterone, DHT, which is something that is linked to androgenic alopecia. So this would be, basically the DHT can affect the hair follicle and keep it in this like stunted phase where it's not growing. And so that can cause hair loss. And that one study didn't measure hair loss. It just, again, looked at the DHT, the dihydrotestosterone levels. It's never been replicated. After so many decades, it's never had any animal evidence showing that this actually causes hair loss. Nothing has really come up showing that this is something to be concerned about. So I take it as, okay, it's like a one-off thing. Who knows what was going on here? But like you would think if it was real, it would be replicated after, when was it published?
2009.
2009.
Yeah, so it was a group of rugby players. They were given 25 grams a day of creatine. But there was actually a randomized control trial done in 2025, this year, with 45 resistant trained men all given 5 grams a day of creatine over 12 weeks. And there was no significant difference found in their hair outcomes or DHT versus placebo.
There we go. When was that published?
2025.
Oh, this year.
A randomized control trial.
Amazing. Thank you.
PubMed.
Well, I mean, to get also to your other point about the water weight gain, I know this is a real thing because also several of my girlfriends were concerned about this as well. And it's funny, creatine does bring water into the cell, but that's actually it's not a bad thing, right? And you're really not going to get a big gain in weight. I mean, I can't imagine. There's nothing more than like 2 pounds, if anything at all. So I do think that is sort of something that's, it's a fear that's not justified, in my opinion. I mean, you gain 4 pounds of water weight when you're on your menstrual cycle.
Yeah. You mentioned fasting.
Yeah.
There's been lots of conversation around fasting, around whether it's good, bad, how long to fast, or whether just restricting your calories is the same as fasting. A lot of people talk about autophagy, and my girlfriend talks about water fasting. What is your perspective on the role of fasting, how we should do it, if we should do it, when we should do it, who should do it?
I think it depends on what your goal is. So you mentioned people talk about calorie restriction and really, is the fasting just about the calorie restriction? And I think when it comes to weight loss, losing weight, predominantly, hopefully fat, not muscle, then calorie restriction is the main thing to do here. And intermittent fasting is sort of a tool to get you there. In other words, people that are doing intermittent fasting tend to eat fewer calories. And that's been shown in several studies, even if they aren't counting their calories, because they are limited in the amount of time they're eating. And then they're fasting for a longer period of time. They end up just consuming naturally fewer calories.
Being in a calorie deficit, is that going to put you into the ketogenic state that you get from not fasting?
No, not necessarily. No, it's not. So you can be in a calorie deficit, but it depends, right? So when you're in the fasted state, what's important here is you're activating a bunch of pathways that don't become active when you're in a fed state. And there's a lot of biochemical reactions that sort of dictate all that. But you mentioned autophagy, right? And that's the big one. That's happening only when you're really in a fasted state.
What is it?
There's different types of it. So generally speaking, it's the clearing out of damaged stuff within your cell. So what is damaged stuff? It can be protein aggregates. For example, if we think about in neurons, amyloid beta protein aggregates. So autophagy could play a role in clearing that out.
The plaques and stuff you get in your brain.
Exactly. But you also get plaques in your cardiovascular system. So autophagy can play a role in clearing that out. But it also can be fragments of DNA. It can be, all sorts of gunk and stuff that just can accumulate inside of your cell. And so you're kind of getting rid of that. Also, it can be even on the level of, let's say, it's the organelle level. So you can actually have your mitochondria. We talked about mitochondria being the major source of energy inside of our cells. Mitochondria are very important for the health of all of our cells, our neurons, our muscle, because they produce energy. But mitochondria also accumulate a lot of damage quite easily because they produce energy and they use oxygen to do that. They make a lot of what's called reactive oxygen species. So these are things that can really react with our DNA, with proteins inside of our cells, with lipids, so the cell membranes. So your mitochondria don't really have a repair system like our DNA does. So we have DNA repair enzymes that can repair damage to our DNA, right? That's where magnesium comes in. Magnesium is required for these enzymes to be activated to repair damage to our DNA to prevent cancer. Our mitochondria don't have that kind of repair system. They have another repair system, and one of it is what's called mitophagy, which is kind of a sub-part of autophagy. And it's where the mitochondria, they accumulate damage. You can essentially take that mitochondria and get rid of it, right? Or a piece of that mitochondria that damaged and get rid of it through this sort of autophagy type of thing, but it's called mitophagy. And that happens with other types of what are called organelles within our cells. So this autophagy process, this autophagy is sort of a general term, but it's essentially the cleaning out of damage. It's the repair process for damage. And it's something that happens most of the time when we're in a fasted state, which typically happens when we're sleeping.
How long do I have to be in a fasted state for?
I mean, it depends. I would say that we haven't really worked that out great in humans because people aren't measuring biomarkers of autophagy in humans. There have been some studies that have looked at being in a fasted state for like 16 hours. And essentially, once you break through that part of depleting all your liver glycogen, that's an important, precursor for activating autophagy. So I mentioned earlier that happens after about 12 hours, right? So as you get to 12, 13, 14, 15, 16 hours, then you're probably getting to that state of autophagy. However, there's such limited evidence on that in humans. A lot of it comes from animal studies. With that caveat, I will say that you can get a lot of benefits. So some of the metabolic benefits for fasting include improved glucose levels, improved blood pressure regulation, metabolic effects, improved, for example, weight loss, right? Now, can you get all of that from just doing caloric restriction versus doing like this intermittent fasting, right? You can get a lot of it, but there have been studies showing that doing this sort of intermittent fasting is beneficial for some of these metabolic parameters outside of being in a caloric deficit.
What does that mean, metabolic parameters?
Again, glucose regulation,
Okay.
blood pressure, your blood pressure control as well. So these things have been shown in people that are doing time-restricted eating. So they're basically doing a type of intermittent fasting where, especially if they're doing a really compressed window, so they're eating all their food within 6 hours and then fasting for like 18 hours, that's really beneficial, right? And even if they have the same amount of calories as people that are calorically restricted, they've compared those head to head. People that are doing the fasting have better improvements in their glucose regulation, better improvements in their blood pressure than people that are even still eating fewer calories but not doing the fasting component.
So what would you recommend for the average person? I asked you earlier on to give me a sort of a perfect prescription of what I should do in terms of fasting. On a daily basis, you think I should have eating sort of fasted windows of, 12 to 20 hours?
I think it really depends on what you're looking for. And personally, if you are wanting to have this more autophagy kind of potentially autophagy activation where you're clearing away stuff within your cells, again, we don't really know the hard number yet. But I would say, yeah, you probably want to be around a 16-hour window of not eating.
What do you do?
I mean, it depends on the day.
On an optimal day.
Most of the time, I'm probably eating all of my food within a 10-hour window, and so I'm fasted for 14 hours. But optimally, it all depends on my family and eating dinner with my family and what's going on.
Do you ever do longer fasts?
I don't do. I mean, I would say a day is the longest that I do. But I do a lot of exercise on top of that. And so you can kind of kick yourself into that autophagy state a little bit more because it's kind of we talked about this, it's a way of sort of supercharging your ketosis. And so if you're exercising and fasting, that kind of supercharges that whole autophagy system as well. But I do think it's a kind of an interesting idea to do some longer fasts, maybe once a year or once a quarter, depending.
Why?
Because you are activating that repair process. Now, you have to do resistance training because you don't want to lose muscle mass. Protein is important. It's one of the signals for, muscle protein synthesis, which is essential for, gaining muscle mass and maintaining muscle mass, right?
So after a fast, you want to break the fast with something protein rich?
Absolutely. Definitely protein rich, for sure. But I think also during a fast, if you can do some kind of you want to stimulate your muscles with mechanical force because that's the other signal to stimulate muscle protein synthesis. And so I think one of the biggest concerns people had with fasting, and this was over the last 5 years or so, is that studies have shown people that undergo intermittent fasting tend to lose muscle mass because they're eating fewer meals, they're not getting as much protein, and perhaps they're not doing resistance training. Now, there have been other studies that have looked at people doing intermittent fasting and resistance training, and they don't lose muscle mass because they're getting that mechanical stimulation of their muscles, which is preventing the loss of muscle mass. And so I think the take home here is if you are doing intermittent fasting, you want to make sure you're getting all your protein, 1.2 to 1.6 grams of protein per kilogram body weight per day, depending on how much you're resistance training. And you want to make sure you're getting your protein in that small window that you're eating, and you want to make sure that you're doing resistance training as well. Those are two really important things if you are going to do intermittent fasting.
There was a study I read which is linked to that, which said, linked to that but sort of adjacent, that says in 9 human trials they found that 23% of people enjoyed better sleep after intermittent fasting, which I thought was interesting.
Yeah.
Causation's obviously hard to establish there, but...
Right. I think, and that brings us to this other sort of aspect of intermittent fasting, which is time-restricted eating. Essentially, what's the best thing to do is really you want to eat within an earlier time window. And there's a lot of reasons for that. One of them is that when you eat later in the day, let's say 8 o'clock at night, 9 o'clock at night, your body's starting to naturally make melatonin. That's a hormone that's involved in helping you get sleepy. Well, melatonin also inhibits the production of insulin. And so you basically will have elevated blood glucose levels when you're eating later in the day because your glucose regulation is impaired somewhat, right? So it's better to try to eat your food early in the day, but then there's also this area of you want to probably stop eating 3 hours before your natural bedtime. And that does affect sleep. So if you think about it, when you're sleeping, you don't want to be digesting. There's all these things that are activated during digestion, and that's going to affect the way you sleep. And so there are some interesting studies that have found that people sleep better if they stop eating at least 3 hours before bed. That is something that I do try to do almost daily. And It's also something that was very interesting. I think a friend of mine, Dr. Sachin Panda at the Salk Institute, was one of the first people to observe that. He's got this app that he has called My Circadian Clock, and he's used this app over the years for clinical trials where people will take a picture of their food and it timestamps the foods that he knows what time they're eating and when they stop eating. And people that are part of this trial started to send him comments going, oh, I stopped eating earlier and all of a sudden my sleep is better. And after you start to get about 10, 20, 30 people making the same comment, you start to go, wait a minute, there's something here, right? And so I think he was one of the first people to actually observe that correlation between stop eating earlier and sleeping better.
Well, you talked about protein earlier when we were talking about resistance training and fasting. When should I... Someone told me that you're supposed to take protein straight after you do a resistance training workout, straight after you lift the weights, like 30 minutes after. Does it matter?
Well, that's what was thought, I think, previously for I don't know how many years. It was thought there was an anabolic window, right, where you want to take in this protein within 30 minutes to an hour of doing your resistance training. And that way, the amino acids that are anabolic, like leucine, are going into the muscle and building muscle, essentially, right? We now know that it's not really an anabolic window. It's about your daily protein intake, because what exercise is doing, what the resistance training is doing, is it's sensitizing all your transporters in your muscle to amino acids. And that's happening over the course of 24 hours. So you can take that protein in within that day and it really still do the same thing. So I don't think you have to slam your protein shake within 30 minutes to an hour. Maybe if you're like a bodybuilder and you're really trying to get that little tiny percentage, maybe you'll have a little bit of a benefit. But generally speaking, most people, what you want to look at is your daily protein intake, because that's essentially the most important thing. And the exercise itself is sensitizing all these, transporters on your muscle that are allowing the amino acids to come in and build protein, increase muscle protein synthesis.
Whether you are a novice or you've been in the tax and bookkeeping industry for years, if you want to work with an experienced team of professionals who are invested in your learning and growth, there's a real career opportunity with our sponsor, Intuit, the maker of TurboTax and QuickBooks. Their self-paced training, Intuit Academy, presents you with a pathway to gain the necessary skills that you'll need to feel confident expanding your career within tax and bookkeeping. And their team is extremely supportive too, with a large network of experienced, credentialed professionals right by your side as you learn and gain experience. On top of all of this upskilling, they also offer flexible working schedules, whether that's full-time, part-time, virtual, on-site, or even letting you select your hours to grow at the pace that you want to grow at. Intuit is currently growing their network of tax and bookkeeping professionals. So if you want to build a career with them on your own terms, just head to intuit.com/expert. I'll put that on the screen. That's intuit.com/expert. I've just invested millions into this and become a co-owner of the company. It's a company called Ketone IQ, and the story is quite interesting. I started talking about ketosis on this podcast and the fact that I'm very low carb, very, very low sugar, and my body produces ketones, which have made me incredibly focused, have improved my endurance, have improved my mood, and have made me more capable at doing what I do here. And because I was talking about it on the podcast, a couple of weeks later, these showed up on my desk in my HQ in London, these little shots. And oh my God, the impact this had on my ability to articulate myself, on my focus, on my workouts, on my mood, on stopping me crashing throughout the day was so profound that I reached out to the founders of the company, and now I'm a co-owner of this business. I highly, highly recommend you look into this. I highly recommend you look at the science behind the product. If you want to try it for yourself, visit ketone.com/Stephen for 30% off your subscription order, and you'll also get a free gift with your second shipment. That's ketone.com/Stephen. And I'm so honored that once again a company I own can sponsor my podcast. There's a term that you've used a few times which I'm not super well educated on, which is insulin resistance. What is insulin resistance? And is that something associated with diabetes? And therefore, does someone like me need to care? I don't have diabetes.
Okay, let's take a step back. When you are eating something that is going to raise your blood glucose levels, right?
So like a piece of bread or some sugar or whatever.
Right. So essentially, if you're increasing that glucose spike in your bloodstream, you want to have that glucose go somewhere. You want it to go to your muscle, or sometimes it goes to your adipose tissue. But in order to do that, you have to activate insulin. And insulin then causes these transporters that usually aren't active to kind of come up and take in the glucose. So insulin resistance is when you're basically constantly activating that pathway, such that your cells don't respond to the insulin like they used to. And so the insulin isn't doing its job as well. And so essentially your blood glucose levels stay elevated, and that causes all sorts of damage, the glycation and things like that we've talked about.
So it's really insulin failure. Insulin's failing to do its job.
Well, it depends, because you're still making the insulin, but it's essentially not, the insulin receptor isn't responding to that insulin. And so it's not doing its job. Yes, it's not doing its job, but it's different from type 1 diabetes in the sense where you're type 1 diabetes, you're actually not even making the insulin, right? So that's very different. So yeah, insulin is not able to do its job, but insulin resistance, and I mean, there's so many different diseases that's been linked to, but I think everything is so complicated. So I don't know that everything's due to insulin resistance, but it's like one component of, something that's accelerating the way you age.
I had a light doctor in here the other day, a sunlight doctor the other day, and we spent a lot of time talking about light and sunlight. And one of the things that I've been really fascinated by is red light therapy over the last couple of months. Do you have a sort of red light therapy routine? It's
interesting that you ask. So red light therapy in the scientific literature called photobiomodulation. I know that's a complicated word, but there's essentially a variety of different wavelengths that can be used to stimulate physiological processes like mitochondria inside of your cells to do stuff, right? I now am convinced that red light therapy plays a role in helping with skin aging. So I do have a mask. It helps with skin aging and wrinkles. There have been enough studies now that is pretty convincing that it does seem to improve the way skin ages. I do think the important thing here is the parameters that are done. It's not just wavelength, but it's also like the energy, so irradiance. And so you have to kind of look at all those parameters and make sure you can replicate that with whatever product that you're using.
What about infrared saunas?
Infrared saunas or traditional saunas?
The infrared ones.
Infrared. So infrared saunas are a type of sauna that is using, essentially infrared radiation, right? Infrared wavelengths to heat up the body. And so they're not very hot. So if you look at like the ambient temperature in an infrared sauna, it goes up to like 140 degrees Fahrenheit, which is very different from a traditional sauna. So infrared saunas don't have all the same benefits as a traditional hot sauna, something that maybe goes up to 175, 180 degrees Fahrenheit, unless you are staying in that infrared sauna for like a very long time, perhaps even twice as long as you would or more in a traditional sauna. The interesting thing about infrared saunas, I would say, so a colleague of mine, a collaborator of mine, Dr. Ashley Mason, she's at UCSF, and she's been doing what's called the heat bed study. And it's an infrared sauna that is essentially a head out heat bed. So your whole body is in this infrared sort of bed, but your head is out of it. So your head's not in it. And people, she's now done a couple of studies, and the most recent study has been done in people with major depressive disorder. So they have depression, and these people are doing an infrared sauna to a pretty extreme degree. So she's elevating their core body temperature by around 2 degrees. So they're essentially getting in a somewhat feverish state. And in order to do that, I mean, these people are in this infrared sauna for well over an hour. So not like most people that are doing infrared saunas. They're probably staying there for like 20, 30 minutes, right? So people are getting very, very hot to the point where their core body temperature is going up to, increasing to like 1.5 to 2 degrees, right? And she's looking at the effects on depression. And so what she has found is kind of amazing, is that people that are doing this infrared sauna, this heat bed, and doing cognitive behavioral therapy, CBT, they are experiencing massive antidepressant effects. So there's something called the Hamilton scale, which is like a battery of tests that are done to assess depression. And just to give you like some sort of basis of like, if there's something considered clinically significant, then you have like a 3-point change on that scale. Well, essentially, this infrared sauna plus the cognitive behavioral therapy improved the Hamilton scale, assessment by 16 points. And these are people that did 4 or 8 rounds of it. So it was over the course of either 1 month or 2 months. Some people just couldn't finish it because it is pretty intense. Like you're heating your body up quite a lot, and you're sitting in this, infrared sauna for over an hour, and it's a pretty intense. But the magnitude of effect on the antidepressant effect it's stunning. And this kind of all stems back from her mentor, Dr. Charles Raison, his research that was essentially like an infrared sauna. So he did something, this was, back in 2016. He did this study where he put people in this sort of infrared sauna-like thing, and it elevated their core body temperature, again, by about 2 degrees. They're people with major depressive disorder. Or he gave them a sham control. So it was kind of hot, and people were thinking they were getting the treatment, but it was actually a placebo, okay? It was enough for them to think they were getting the treatment, but it wasn't elevating their core body temperature enough. And they did 1 treatment of this, okay? And he showed that the people that did 1 treatment of this had an antidepressant effect that lasted 6 weeks later after 1 treatment. Sham control didn't get this. Beautiful study. Ashley kind of followed on that study and showed multiple sessions of it really had an even more robust effect. But I say this because I don't want to say infrared saunas aren't great. However, there's a lot of benefits that have been related to more hot traditional types of saunas, Finnish saunas, for example, traditional saunas that are hotter, right? And so you're staying in these 175, 180 degree sauna for like 20 minutes, and it's associated with lower cardiovascular related mortality. So if you're doing it 4 to 7 times a week, that's associated with a 50% lower cardiovascular related mortality versus doing it 1 time a week. Or all-cause mortality. It's associated with 40% lower all-cause mortality versus doing it 1 time a week. So
what's going on there?
Right, exactly. What's going on there? And so the really fascinating thing to me about this deliberate heat exposure from a sauna is that it is sort of mimicking moderate intensity aerobic exercise. And this has actually been shown. It's been compared head to head to moderate intensity, like cycling on a stationary bike. A lot of the physiological responses, so your core body temperature goes up, your heart rate goes up, right? When you're exercising, your heart rate goes up. Same thing happens when you're in a hot sauna, your heart rate goes up. Your cardiac output is increased, right? Your blood flow is increasing. All these things are happening, and they're very similar. Exercise, heat stress. You're sweating, right, to cool down your body. So it's a way of sort of mimicking this moderate intensity exercise. That doesn't really happen in an infrared sauna if you do the same amount of time as you're doing in a hot sauna. Now, perhaps if you increase that time, it would happen. But there's all these benefits that are happening with just doing a deliberate heat exposure from a sauna that seem to not only sort of mimic cardiovascular exercise, but they add on to it. So we were talking about cardiorespiratory fitness and how important that is for longevity, right? Where there have been studies that have looked at people that exercise on a stationary bike, or they exercise on a stationary bike and then follow that up with a 15-minute sauna. And it's been shown that those people that do the 15-minute sauna on top of the exercise have a higher improvement in their cardiorespiratory fitness. They have more improved levels of their cholesterol and lipids. Their blood pressure improvements were greater. So there's this additive effect of adding on the deliberate heat exposure with the exercise that isn't happening with exercise alone. So again, that's sort of just more evidence of why, doing a deliberate heat exposure like a sauna, in fact, hot tubs, that's something that's also been shown to improve blood pressure. In fact, a study just came out a couple of weeks ago showing that a hot tub is very beneficial for improving blood pressure, for doing all the same things that a sauna does, which is kind of exciting because not everyone has a sauna.
I heard that you sometimes rehearse important talks and studies in saunas.
Yeah. I mean, this started back when I was in graduate school. I used to go to this, I lived across the street from a YMCA, and I used to go to this sauna and use the sauna before I would go into my lab and do experiments. And there's a couple things I noticed. One, I was able to handle stress better. My stress of, failed experiments, mentors putting all this pressure on me, all that stuff, right? If I went to the sauna beforehand, I was very much, it's like I was more resilient to the stress. And that was when I started to look into the effects on the brain. And that's where I also am very interested in depression research as well, right? Because you're causing like brain resilience. But once I started to realize like this is affecting my mood, this is affecting my ability to handle stress, I was using the sauna like every day. I mean, I was like religious about it. It was crazy. I mean, it was like 6 to 7 days a week I was going in that sauna. And because it was like using it every day, you have to multitask. You only have so much time in the day, right? And so I'd start rehearsing my presentations, like going through them in my mind while I'm sitting in the sauna with these other people from the YMCA who probably think I'm crazy because I'm sitting here like saying things. But I noticed that I was able to remember things better if I had gone through them in my head with the heat. And it wasn't until many, many years later. I mean, I kept doing that. Like even sometimes when I travel and I'm giving a presentation or a talk, I'll get in the hot bath in my hotel room and I'll just lay in the hot bath and I just go through my talk in my head. Or I'll like look at my notes and like if I forget something, I'll go through it in my head. And it wasn't until several years later that I started looking into the science behind that. Like there's something going on here. What is going on? And I found that actually when you go into the sauna, so there's a lot of physiological changes that happen. Growth hormone goes up. In fact, depending on the temperature and duration, growth hormone can go up anywhere between 2-fold to like 16-fold, like insane levels of growth hormone. But there's something else that goes up called IGF-2. And that is associated with improving memory and learning. And so there have been animal studies that have done this. And so I've kind of connected the dots here and go, maybe that's why. I don't really know why. I mean, sometimes just like a very strong emotional response can sort of help you remember something. And you are, at the end of the day, causing a very strong stress response when you're getting in the heat. So I like to use the sauna for a lot of things. I do it. It depends on the day. Sometimes I like to do it before bed. So I'll do like the hot tub or the sauna. It improves sleep. It improves my sleep. And that has to do with the growth hormone. It has to do with what are called somnogenic cytokines. These are inflammatory molecules that are made that cause sleepiness. So if you think about when you're sick and you have inflammation going on, when you have an illness, you're very tired, you're sleepy. You're producing a lot of what are called somnogenic cytokines. These are cytokines that are inflammation molecules that are involved in making you sleepy. Those are also produced when you are undergoing deliberate heat exposure, like a hot tub, and that's been shown. As well as a sauna. So sometimes I like to do the sauna at night, like to relax and help my sleep. Sometimes I like to do it after a workout to extend my workout, like the study I talked about where you're improving your cardiorespiratory fitness as well.
Would you like some tea? My team can make you some tea if you'd like some tea.
I would love some loose leaf tea in a metal cup.
Why don't you want this tea?
What you're doing here is tapping into my – sometimes my friends don't want to talk to me because I'm like the bearer of bad news, where – it's like, what is Rhonda going to tell me now that I shouldn't be doing, that I love doing, right? Another obsession of mine of late has been microplastic exposure. And I know you've talked about this on the podcast before, and it's in the news now. A lot of people are sort of familiar with microplastics, right? Breakdown of plastic particles that are tiny, depending on the size, and getting into our circulation, right? And when you think of microplastics, you think of plastic. When you think of plastic, you think, oh, that plastic water bottle. Yeah, well, I'll just avoid that plastic water bottle, right? What you don't realize is that everything has plastic. So you have here this to-go coffee cup, which I don't know how many coffees and teas I've had in a to-go coffee cup, but it's hundreds and hundreds. And the thing that's so disturbing is I learned that, these all of these paper-looking coffee cups are actually lined with plastic. They're lined with a plastic liner to prevent like the liquid to, leaching into the paper, right? And that plastic lining, when you add heat to it, i.e. boiling water for tea or hot coffee, it accelerates the breakdown of the plastic lining. So you're drinking microplastic beverages and also the chemicals associated with them. So there was this classic study that was done that showed heating up plastic essentially causes these toxic, plastic-associated chemicals like BPA, bisphenol A, which is an endocrine disruptor. It disrupts hormones. It sort of mimics estrogen. So, it's sometimes like called an estrogen mimetic. It causes that to leach into your beverage 55 times more.
55 times?
55-fold, yes.
Which is 5,500%.
It's a lot, yes. And so you're talking about drinking, plastic chemicals and microplastics. So that was like, okay, well, fine. I'm going to bring my mug in anytime I'm traveling and ask them to put my coffee in that. So I see so many people with these to-go, paper cups and they're drinking coffee in it. And it's like, it's so hard for me because I realize it's like this plastic soup that you're drinking. Now you have a tea bag on top of that. And that is something that there've been over the course of the last 7 or 8 years, there have been studies that have come out that these tea bags are made of, there's plastic polymers in them. And so there's thousands of microplastics that are released in every milliliter of tea from these tea bags. And there's a variety of different tea bags. Essentially all of them release microplastics. The ones that look like they won't, release them. So now, while I used to drink a lot of tea when I'm on the go, I bring my own with me. I bring my own loose leaf tea with a little, one of those little steepers that can steep the tea. And I use that mostly because of the heat, it's accelerating that breakdown. Yes, I'll drink I'll drink water out of a plastic bottle sometimes when I'm traveling because there's no other options. And actually there was a study that just came out. I'm sure you saw it. Did you see the study that showed glass had higher levels? So water that was in glass had higher levels of microplastic than water that was in plastic containers. This was a study that came out of France.
Oh, come on.
You didn't see the study?
No.
Oh my gosh. This is like everywhere. I mean, it came out, I don't know, in the last 2 weeks or so. The study came out of France, and it was essentially showing that glass bottles had more microplastics in the liquid that they contained than plastic bottles, which contain liquid. And you might go, what? That makes no sense, right? I mean, why would the glass have plastic particles at a higher level than a plastic bottle? Well, it turns out that the paint on top of the lid of the glass bottle has plastic polymers in it. And so the paint is flaking off and getting into the water that is contained in the glass bottle. There is, I think, a silver lining here, and that is, well, okay, there might be more microplastics in the beverages that are in the glass bottle compared to the plastic bottle, but the size matters. So it was shown that the size is larger in the glass bottles compared to the plastic bottles. And
the size of the plastic.
The size of the microplastic. And there's a reason why this is important, because microplastics and nanoplastics, as you get smaller in size, they get smaller. They're called nanoplastics. Those are the most dangerous because it can be more easily absorbed in the gut and get into the circulation. If it gets into circulation, it can more easily bypass the blood-brain barrier and get into the brain. Size matters. And so the larger size flaking off from the paint is less likely to be absorbed by the gut and to get into circulation. Now, this has to be shown. I'm sure the study is going to be done next. Like, this is going to be the next study. It hasn't been shown yet.
I've heard you talk about fiber as well playing a role in getting microplastics out of our body.
Okay, so yes, so fiber is interesting. This all comes from animal studies. And fiber seems to play a role in the absorption of microplastics and nanoplastics in your gut cells. And that's really important because if you don't absorb them, it's excreted through feces, right? And it's been shown we only absorb about 1 to 2% of these microplastics that we're ingesting. Fiber, what it does is two things. One, it moves the microplastics through the intestines quicker, right? Which is what fiber does. But I think the more important thing is the type of fiber. So you want this fermentable type of fiber, soluble fiber. That's the kind of fiber that's really good for your gut microbiome. And what that does is it's essentially creating this viscous gel-like, mucousy stuff inside of your gut that encapsulates the microplastics so that it can't be absorbed by the gut what are called the gut epithelial cells. And so if you're essentially not able to absorb those microplastics, then they're not getting into circulation. And that's like the biggest thing that you can do, right? Is not get them into circulation. Now, this is all based on animal evidence. I did speak with a microplastics researcher at Harvard, Dr. Carrie Nadeau, and she wasn't even aware of this. And now she's like on it. So I'm hoping that there'll be some human evidence coming soon looking at whether or not microplastics, if you're eating fiber, if that can basically blunt the absorption of the microplastics into the system. I think people that are eating more fiber in their diet probably are getting less of that microplastics into their system, but that hasn't been shown in humans. It's only been shown in animals.
I'm guessing you don't eat canned soup either.
Yes. Yeah. So the canned soup is interesting. Again, aluminum cans are lined with this plastic, lining, and that prevents the sort of breakdown of the aluminum, right? The metal. Unfortunately, it also causes these chemicals like BPA that are in the plastic lining to leach into in this case, the soup or the beverage or the liquid that they're contained in, right? There was a study that showed, I think it was 1,000% increase of BPA after drinking like soup out of a can versus a soup out of a glass. 1,000% increase in bisphenol A levels. I mean, that is
bisphenol A levels being
BPA,
which is that bad thing in microplastics.
It's one of the bad chemicals in plastics that is an endocrine disruptor. So it's disrupting hormones, and that can play a role in a lot of different things, depending on what we're looking at. So it's hugely important for obviously like neurodevelopment in children. So like pregnant women, but even like, disrupting hormones in general, like mimicking estrogen. I mean, that's not something that guys want to do either, right? So it is something to be aware of. But the thing is that, BPA, there was this beautiful marketing strategy that came out, I don't know how many years ago, but all this BPA was replaced with something else that wasn't BPA. It was BPS. And so now everything is marketed as BPA free. And people think that is like, oh, it's not dangerous. It's BPA free. However, what it's replaced with is doing the same thing as BPA, if not worse. And that's been now shown in multiple studies. So it's also an endocrine disruptor. It's doing the same thing. And yet people think, that it's safe because it's BPA free.
Did you hear about this study of people that live close to a golf course?
Yes. Yeah. There's a study that came out, I don't know how, it was very recent, maybe
2025.
Yeah. So I think it was a couple months ago. And the study showed that people that lived within a mile or so of golf courses had a much higher incidence of Parkinson's disease, right?
It says 126% higher risk.
Right. Okay. So then why is that, right? And this is where I want to get into the pesticides issue, because it's known, like any scientist that's done research in neurodegenerative disease, it's one of the ways that you induce Parkinson's disease in animals is you give them insecticides. You give them essentially a pesticide. So rotenone being one, paraquat. And what that does is a mitochondrial toxin. So it's basically causing mitochondria to die, and then essentially when the mitochondria are dying or apoptosing, the cell undergoes apoptosis and dying. So you can induce Parkinson's disease in mice by giving them these types of these types of insecticides and herbicides. So it's well known that can cause Parkinson's disease. It's important to know that it's mostly the ingestion of it and not the inhalation of it. And that was a big concern because it gets into the water source. And that's what's thought to be the underlying cause. People that are living close to a golf course, it's contaminating the water source essentially. And so people are drinking these pesticides, insecticides and herbicides, right? So a water filter, like a reverse osmosis, water filter or something like that can filter out some of these molecules, hugely important. And I think that's the solution to people that are living near a golf course or people that are living near any sort of agricultural place where they're using a high volume of these types of, herbicides.
What is the most important thing we haven't talked about that we should have talked about, Rhonda?
I think we talked a little bit about magnesium, but I don't know that we talked enough about magnesium. And it is important because it's something that is required for, over 300 different enzymes in your body need it to function properly. So it's what's called a cofactor. And I mentioned DNA repair enzymes. So it's also used to make energy. So you need magnesium to make energy and to use energy. You need magnesium to repair damage that's happening all the time. And close to 50% of the population in the United States does not have adequate levels of magnesium because they're not eating the foods that they need to get the magnesium. Dark leafy greens, I mentioned it's at the center of a chlorophyll molecule. There have been studies that have shown that for every 100 milligram decrease in magnesium intake, there's a 24% increase in pancreatic cancer incidence. And that's in a dose-dependent manner. So you keep going up and up. I think that people don't realize that they're not getting enough magnesium. Magnesium is required to turn vitamin D3 into the steroid hormone. So some people have a magnesium, insufficient amount of magnesium they're taking in, and they're actually not able to make enough vitamin D into that steroid hormone. Again, magnesium is controlling 300 enzymes. Some of those enzymes are actually the ones that are converting vitamin D3 into the steroid hormone. So magnesium is hugely important. It's something that can be easily corrected. The deficiency can be easily corrected by taking a supplement, but also eating more leafy greens, which is the best source of magnesium. The question is, what do supplements do? What kind of supplement do you take? How much should you take? All these things are, I think, questions that people are interested in.
So I've got some magnesium here. Is taking magnesium going to have a positive role then on my speed of aging?
I do think so. I think so. Yes. We talked about cancer incidence, right? Magnesium. So I think magnesium is one of those sort of minerals that is when you don't have enough of it, it's causing that insidious damage over time that accumulates and then rears its ugly head, in the 5th, 6th, 7th decade of life. And that ugly head happens to be cancer. So I do think that if you are able to avoid magnesium deficiency and insufficiency, then you are going to be able to basically make sure there's enough magnesium around for everything in your body to use it with what it needs it for. So,
and I've heard you say that 50% of people are deficient in the United States in magnesium.
Right, close to 50%. And not to mention, you just talked about, electrolytes. Well, athletes, they actually require between 10 to 20% more magnesium than the general population because of their magnesium losses are so great. And so they can be even more deficient. Magnesium is needed for red blood cells. And so, people can have lower energy as well. So magnesium is so important for so many different things. And, like I said, I do think there's a trade-off here where whatever magnesium you are getting from your diet, if you're not getting enough of it, it's probably going to make energy instead of being used to repair damage because you need to make energy every day, right? That's the most important thing. If you don't make energy, you die. You can't survive. So whatever magnesium your body is getting, it's not going to that process of repairing DNA, which doesn't really matter until you're in your, 5th, 6th, 7th decade of life and cancer, risk increases, right? And so there's this idea, this is put out by my mentor, Dr. Bruce Ames, called triage theory, and he's shown some evidence of it. Magnesium is one of them, where magnesium seems to be triaged to energy production at the expense of repairing your DNA.
What does that mean?
It means that if you're not getting enough magnesium through your dietary intake and you're not supplementing with it, whatever magnesium that you're getting, there's 300 different enzymes that need it to do their function, that your body is finding a way to triage it to the most essential functions that are going to basically help with short-term survival.
Triage means it's basically allocating.
Yes, it's allocating it to the processes inside of your body that are essential for short-term survival right now.
Got you.
Long-term health, diseases of aging like cancer, that doesn't matter as much, right?
If you're deficient.
Yeah, your body basically says, no, I'm not going to give whatever precious magnesium I have right now to prevent cancer because I need to live long enough to reproduce and pass on my genes. And cancer doesn't happen until I'm well past that, right? So this idea, it's called the triage theory, and it's been shown for several different micronutrients. Another one is vitamin K. So vitamin K is really high in dark leafy greens. Well, what Bruce has shown is that vitamin K is important for a couple of things. One, it's important for blood coagulation, blood clotting, and that all happens in the liver. You activate proteins in the liver for blood clotting. If you don't have vitamin K, you can't do that. Right? It's one of the reasons why when a baby's first born, they give it a vitamin K shot so that they have blood coagulation.
On your YouTube channel, you made a video about magnesium, which I recommend everybody goes and watches if you are interested in going deeper on this subject. And on your YouTube, I found a stat that said for every 100 milligram drop in magnesium intake is linked to a 24% higher risk of pancreatic cancer.
Yes.
Which is shocking.
It is. And again, it comes down to the DNA repair enzymes that require magnesium to be activated. And if over a lifetime, you're part of that 50% of the population in the United States that doesn't get enough magnesium, then you're talking about not being able to repair damage to your DNA over decades. And essentially what that means is, at some point, damage happens to your DNA in the right part of a gene that is what's called oncogenic. It's cancer causing. And so eventually it's going to cause cancer if you're not able to repair that damage, right? And so getting enough magnesium is important to make sure you're repairing that damage. And it's not only important for cancer, but also all-cause mortality. So there's also studies showing that people with the highest magnesium levels have a 40% lower all-cause mortality than people with the lowest magnesium levels. And they have a 50% lower cancer-related mortality compared to people with the lowest levels. So again, cancer is still in there. And we're seeing that magnesium intake is very important with respect to cancer. And that is something that, people don't realize when they're not getting enough of magnesium in their diet, they're not eating their leafy greens, or they're not taking a supplement, that they're sort of affecting their long-term risk of cancer.
So people with high magnesium levels have a 50% lower risk of cancer death than those with low levels.
Right.
And is that, you obviously can't do like a double-blind placebo-controlled test on that. So they're really establishing causation. So it could be other things like, it could be the other dietary factors that go into that. Maybe if we think about causation, people that eat a lot of hamburgers don't have a lot of like leafy greens.
Exactly. You nailed it. Essentially, magnesium is packaged in these foods that are beneficial, like dark leafy greens, and there's so many other benefits along with them that you can't establish causation and say, aha, it's just the magnesium. I would argue it's probably not just the magnesium, but magnesium does play an important role. It's just, you can't, of course, pinpoint it to just magnesium because you're right. There are many other important healthy things in these in these plants that are beneficial for health as well.
There was a really random thing that I think parents might appreciate us talking about, which was when I was looking at your work, you mentioned this chemical that if parents take while their baby is inside them, mothers take, the baby is smarter?
Yes, choline.
Choline,
yeah. Choline is an essential nutrient that it's really concentrated in egg yolk. That's a really good source of choline. But it's important it's a precursor for the neurotransmitter acetylcholine. It's also important for producing all these epigenetic changes called methylation that regulates the way our genes are expressed. And it's also very important for our cells, like the membranes of our cells. And it makes something called phosphatidylcholine. It's doing so many things is the point I'm getting to. I don't want to get into all this nitty gritty because people can get lost in that. But the point is that pregnant women that were given like the RDA, close to the RDA, it was like 500.
What's the RDA?
The recommended daily allowance. Actually, I think in this case, it was the DRI, the dietary recommended intake. So pregnant women were given close to what is the dietary recommended intake. So they were given 480 milligrams a day of choline, or they were given almost double that. So they were given 930 milligrams a day. And I don't remember what trimester they started in, but they were given this, throughout a certain time frame during pregnancy. And then a variety of cognitive tests were done after the child was born. And the children that were given, the mothers that had children that were given the really high choline intake, the 930 milligrams, scored better on all these IQ tests. And so essentially their children were smarter if their mother had taken choline throughout pregnancy. And I think this is really interesting because it's the one easy thing that people can do. They can supplement with choline, and or they can eat a lot of eggs with egg yolk, which is something I did both during pregnancy. I was eating probably like 6 eggs a day and supplementing with choline. So I was doing both. And every mother wants to think, every parent wants to think that their child is smart, but
I bet your child is smart.
He's a smart cookie, yeah.
How old is he now? Almost 10?
7.
7, okay. We have a closing tradition on this podcast where the last guest leaves a question for the next guest, not knowing who they're leaving it for. And the question left for you, interesting. If you could go back and change one thing about your life, what would it be? And you cannot say nothing. That's what it says.
I would say the one thing that I would change, I'm 47 years old, just turned 47 last month. I have one child. And I think if I could go back in time, I would change my decision to only have one child, and I would have another child.
Why?
Because I love being a mother. I love the joy that children bring to your life. It's unexplainable until you experience it. Everything about it. Helping shape them, learning with them, going through hard times and experiences, but also experiencing the joys. I regret sort of, I had children later in life because I was really pursuing my career. And it is definitely challenging being an entrepreneur that's a mother. I made a decision that I was going to have one child because I wouldn't be able to do as much of what I love doing outside of being a mother if I had more than one child. And now I realize that, say that when I'm older and closer to dying, I know now that I'm not going to think about doing one more podcast when I'm on my deathbed. I'm going to think about all the experiences I've had with my family. And I do have a pretty balanced, I would say balanced personal life and family life with my career. I don't know that it was the easiest decision to make, where I had to sort of give up some of my intellectual pursuit, some of my entrepreneurial, my productivity, essentially. I had to give some of that up to be the best mother that I wanted to be present with my husband and my son, and enjoy everything that I enjoy, because that takes time. And that time that I'm with them, I am not doing my podcasting or my research or any of that, right? And I'm happy with that decision. And in fact, I would even give up more of it for another child. And that's a very personal thing that I'm discussing. So hopefully I'll be okay with it.
It's not the first time I've heard this.
Really?
Yeah, it's not the first time. I hear this a lot, which is fascinating to me, from high-performance women.
It is. It's, I say that it's very hard to be a very high-performing female and a mother at the same time. You either have to sacrifice being present with your family or your health because you don't sleep as much. You're basically not going to be getting as much sleep because you're going to be working rather than sleeping during some of those hours, right? So I do think that it is very challenging, and I'm not saying that there aren't really high-performing mothers out there, but it is a very difficult thing to do.
When you say you made the choice to have one, was that an intentional choice? I.e., you and your partner did family planning and said, we want one? Or was it, because you said your child is 7, you said you're 47. So at 40, obviously it's becomes a little bit more tricky than it does when you're 30s to conceive.
Right. So I think what in my case, I got pregnant when I was 38 for the first time. And I gave birth when I was 39. So I was pretty late already.
Mm-hmm.
And at that point, I didn't, I was so overwhelmed and my productivity had gone down so much just from that event that I was worried that I wouldn't be able to keep it up if I did another one right away, which I had to do because I had waited so long. Now, why did I wait so long? I was pursuing my career, and I would argue now that I could have had a kid in graduate school. I could have had a child as a postdoctoral fellow. But again, it's one of those things where you want to like get to this milestone and then this milestone, and then you want everything to be perfect. And you start to like, this perfectionism can sometimes be a double-edged sword, right?
Yeah.
Where your perfectionism then is like, okay, well, you're going to have a trade-off here.
Yeah.
And that trade-off for me was my reproductive lifespan. I was older when I started having children. Now, there's a lot of technologies out there now that can help with that. But at, 47, it's, I would say, not looking good.
I think I ask about this, and I'm curious about this because me and my partner, I'm 32, she's turned 33 last week. We don't have any kids. We've been together for almost 7 years now, I think. And so you can imagine in my life how easy it would be to make excuses that I need to get through this year because this big thing's happening, or I'm moving to LA, so now's not the right time. And then she's got her business going on, so now's not the right time for her. And she's traveling and doing these retreats around the world, so that's not perfect timing. And then because of this podcast, I've played this scenario forward because I get to meet people who are a little bit further down the line than me. And I get to ask them about their regrets and the decisions they wish they'd made. And were they intentional about family planning? Did they wish they'd done it earlier? And the thing it's changed in me is it's made me realize that to start the process, if it's something I want to do, well before I'm ready. Because whether we like it or not, there is a biological clock. And the thing that I've observed in the guests, specifically high-performance women, whether Ronda Rousey, the UFC champion, who I sat and interviewed and who was in tears talking about her failed IVF for the 5th, 6th, 7th time, or other women that I've sat here and interviewed and looked in their faces, is the regret of having that decision taken away from you is going to be much, much worse than the inconvenience of the choosing an imperfect time to have the kid. So funnily enough, people don't really know this because I don't talk about this, but I walked away from this podcast just after hearing this story over and over again. And I went to the women in my lives and I was like, it's like super annoying being that guy, because especially as a guy saying it, I'm like, by the way, family planning as early as possible is probably a good idea. And whether that means freezing your eggs or freezing your embryos or just giving yourself the option in the future is probably a good idea. And it was so interesting to actually see the reaction to me saying that to some of the women in my life that I care about, like my siblings or my partner, because upon saying it, it wasn't incredibly well received because I think it's a confronting thing to say to somebody, because there's a bit of a stigma associated with like freezing your eggs and IVF and freezing your embryos. And even with my partner, the first time I said it to her, it was almost as if I was like insulting her. That's almost the how I thought she took it for the first 3 or 4 minutes. But then when I explained what I was saying by like, let's give ourselves the option when we're older. Let's just give ourselves the option. And also, if you go through these procedures when you're younger, you have higher quality yield from the eggs you freeze or the embryos you freeze. Let's just give ourselves the option. And then she kind of turned 5 minutes into the conversation, and then she got super excited about it like 15 minutes in, and now we're like super excited. So like we're trying to conceive, but also we're going to be freezing our eggs and freezing embryos in this year in September, and I've just tried to be a really big influence to the women in my life to like give yourself the option. And I say this because I've seen the regret on this podcast. And that's what I'm saying. And I think all people that can, and I know it's expensive, as early as you can, should consider the fact that we live in a world that is driving productivity, that is making us work later and later in life, that is making us more obsessed with our careers. And without us really knowing it, there is a clock and it's robbing us of the option to make family planning decisions.
100% agree. I I can't agree more. Exclamation, everything you just said. I mean, if I had frozen my eggs, or we had done, IVF and frozen embryos that were viable and healthy, then we'd have the option, right? I mean, it's so true. And I don't know, I think I was just really blinded by and overwhelmed by, how much work I have to do, and thinking, oh, there's no way I could do more than one. Because again, when I'm a mother, I go all in.
Yeah.
When I'm a podcaster, I go all in.
That's exactly what you're doing.
It's not just, when I have a guest on, like, I really I need to be really interested in them. And, so it's all in, but not giving myself that option is a big regret, where at least if I had frozen my eggs down, then I would be at a point now. If I had done this, when I was 39 or 40, or even if I had done it the first time, when I was earlier in my 30s, I should have done that, but I just didn't have the foresight enough to do that, and I do regret it. So it's great. It's great that you talk about it to the women that are in your life, and even on the podcast.
We're really bad at forecasting the fact that we will change. And I think this is really at the heart of it. We're really bad at forecasting the fact that our current state of mind might not be our future state of mind. But you've only got to look backwards in your life and realize how different you were and how you think and what your priorities were. I was in nightclubs at 18 and 19. There's nothing, for me, going to a nightclub now would be like a form of it'd be like waterboarding me. It'd be like torture. I changed. And so at 35, at 40, at 45, there's a high probability that I'm going to have a different perspective than the one I have now. So give myself the fucking option at 45. So that's kind of how I think about it. And I say this out publicly because I just think I don't like seeing that regret in people.
It's hard. Yeah, it's definitely hard. Thankfully, I do have this joy in my life, and I'm so glad I have that. And
I have to acknowledge the fact that many people, even if they did want the option for fertility reasons, can't have children. So it's still not an option for everybody, because there are, people have certain health complications and other issues which prevent them from having kids, even if they wanted to, and even if they're young. And I've got friends in my life that unfortunately are in that situation. But yeah, thank you so much for the work that you do. It's really, really important work, in part because you're so unbelievably engaging, but because of your obsession, you're so unbelievably rigorous and in the detail of the things you talk about. And as you said, there's so many people around the world, and I know because we meet them wherever we go in the world, that don't have access to this information. They're not going to be on PubMed reading through the journals and trying to distill these big words. And I think you do a brilliant job of educating many, many millions of people in every corner of the world through your YouTube channel and your Instagram, etc. And making these complicated things accessible. And if you're successful in that, which you very much are, you're tilting the trajectory of their life, but also therefore their future and their kids' lives and their kids' lives. And that's a really wonderful thing. And we need more public educators like you that have the talent of articulation and engagement that you do. They're very, very rare and hard to come by. I do a podcast, so I look at all these people, and you're the very, very best at it. And you've done it for so unbelievably long, and that's why. So thank you so much for educating us and allowing us to live the future that will be most conducive with our health and happiness.
Well, thank you so much, Stephen, for the really engaging conversation and for asking the hard questions.
Thank you. Just give me 30 seconds of your time. Two things I wanted to say. The first thing is a huge thank you for listening and tuning into the show week after week. It means the world to all of us, and this really is a dream that we absolutely never had and couldn't have imagined getting to this place. But secondly, it's a dream where we feel like we're only just getting started. And if you enjoy what we do here, please join the 24% of people that listen to this podcast regularly and follow us on this app. Here's a promise I'm going to make to you. I'm going to do everything in my power to make this show as good as I can now and into the future. We're going to deliver the guests that you want me to speak to, and we're going to continue to keep doing all of the things you love about this show. Thank you.